to anyone that is keeping the day of Shavuot today. So obviously I'm not by myself, and I don't
Right.
have a normal background. So I'm blessed to be joined by George from Geotruth. So I'll officially introduce him in a minute after I say what's up to some peeps in the chat because it's been a bit since I've done a live stream. There's Josh, Tyler, Tracy, Robert Daniels. Hello, hello, everybody. Let's see. That's all I see right now.
Right.
So hello, sir. How are you?
Doing good. Doing good. A little nervous.
It's your first live
first
stream?
live stream.
Oh
Yeah.
man.
Yeah.
Oh man.
It's been great having you and Candace here for the past couple of days for celebrating Shabbat yesterday and then Shavuot today and a couple of things we're going to do later on, a few more days. But in our fellowship and everything's been great by Yahweh. It's been a great time. Got to know each other better. And so I'm prepared for this. I have a Geotruth channel, and basically it's on YouTube. I got about 40 subscribers. I'm not looking for that. I'm just looking to place truth somewhere, Yah's truth. I have my first video is called Earth's Geometry, and it basically proves and shows that the Earth is a circular level plane, and I prove that the surface of water never bends or curves, and I've proved that through actual data from the government, the U.S. Geological Survey, as well as Google Maps.
Yeah, and you'll see that presentation. Here's what Josh thinks about George. He's the man, a genius in the community.
Oh, thanks, Josh, but I don't think so.
You want to pull up the presentation real quick so I can bring it into the StreamYard, and we'll get you rocking.
Okay, hold on here.
So just give us a minute or two, everybody, and we'll get his. All right, there we go. Awesome. So get you on there. All right, 1 second, and then we'll have everything in the studio we need to rock and roll. All right, can anybody give us a 1 to make sure our audio is good? Since I'm obviously not at my house, I'm at his house.
Right.
To make sure everybody's hearing us on the other end, and make sure to subscribe to George's channel. I have it on top of the description. And if Tyler or Wendy, if you're in the chat, if you want to share his, all right, we got a 1 sweet. So yeah, if you want to go ahead and subscribe now or later, probably preferable after the presentation. Oh, let me say something real quick.
Sure.
Let me read that real quick. So just a disclaimer. This is George's presentation. So it's interesting. So he sends me and Josh, a few other brothers that have ministries, letters, and so he sent. How many pages was it? About 20 of the original presentation.
More than that, maybe 30.
And so I looked at it, and I'm like, so he is an engineer. He has a degree in civil engineer, and he's an architect. So he's a. I mean, I thought I was intelligent until I started looking at his
intelligent.
Yes, I am.
Everybody has different things that they want to do.
Everybody has different gifting. This is his gift.
Right.
So I looked at his presentation. I'm like, oh man, I need him here to like explain this to me. So we've been at their house for the last 3 days, and we have been like talking about cosmology nonstop, and he's showed me some stuff that I've never seen on the Gleason map before or understood. So he's really helped me wrap my brain around this. So this is his presentation. Normally I have a presentation myself. Actually, I do need to bring my back up I guess it's all right. No worries. So just for a future reference, if somebody watches this on the replay and you have a question about one of his slides, and if I'm not able to answer it, just to cover yourself, tag him in the comments. So do the @ symbol and then Geotruth, and so it'll tag him in that comment, and he'll be able to see it. But if you just put it in there, he won't be able to. So just keep that in mind if you're watching this on the replay. So
yeah,
I actually do need to bring that back up. All right, we're working on getting our junk together over here on this end. All right, so where's mine? Real fast. Where are we? All right, there we are. All right, so again, this is the Truth About Cosmology series. So this is going to be episode 24. The name of it is Truth About the Sun and the Moon. So
By the way, he's got the wrong sun on here, but that's okay.
Yeah. He'll forgive me for putting the CGI sun up, so everybody can laugh about that in the chat. Ha ha. So yeah, definitely, I should have put a real picture. And so, if you want to do a little deeper dive after this live stream, because we're going to be talking about sun and moon, check out when me and Ken Heiderbrecht from Hanging on His Word talked about the greater light on episode 9, and then episode 10. These are, you can find these videos in the Truth About Cosmology playlist. Me and Lucas from Saving the Trumpet Prepper talked about the lesser light, aka the moon, in episode 10. So that's all of my amazingly long presentation. Now we'll bring George's back up. So if you want to, let's see, you want to pull that up for me again? Is it right? Is it on the desktop? Or did you have to look for it in
there? It's right there.
Okay, nice. All right, here we go. Getting our jump together. All right, so I'm going to pass it over to the man himself, and he's going to educate y'all on a lot of stuff. So get your thinking cap on, because you're about to learn something, I guarantee. Regardless of how long you've been researching the truth about creation, you're going to learn something new today. This is stuff I've been researching for about 2 years, and he showed me some stuff that I've never seen before. So you're in for a treat.
All right. So I came to understand that the Earth is a circular level plane about 3 years ago. And so I've been looking at and researching it, looking at the scriptures, trying to also use more scientific information. And my approach for Geotruth is a little bit different. I want to reach out to people that are atheists, they don't believe in a God, or people that are Christians, but they don't really believe in the true word of God that talks about his creation. And so I'm trying to get them to realize through science first, the truth that what Yahweh's word says. And then I back it up later on in the presentation on scripture from Almighty Yahweh. So this one's going to be about the sun and the moon. It took me a long time to understand. It took me over a year to understand navigation, because I was trying to figure it out. How's the navigation work on the circular level plane, the Gleason's map, and the globe map? So I'm going to start off here with what NASA says from the sun about the sun and the moon. They tell us, and there's references here. There's actually places that I got it on the web. The sun has a radius of about 435 miles, which is a diameter of 870 miles. Sun is about
135,000. You mean?
870,000 miles in diameter. The sun is about 93 miles from the Earth, and then they say this about the moon, that it has a radius of 2,160 miles in diameter, and the moon's about 855 miles from the Earth. So this next slide is going to basically look at the distance to diameter ratio. That would be the perspective of the distances for each one. So we're also going to use true scientific methods to verify this data. We can, first of all, use our visual observations. The best way to verify things that we can see or hear, our senses are extremely good for determining what we're seeing. So we don't want to just discount that. We want to look at our eyes basically see, the sun and the moon look close to size, but a lot of people can't tell the sun because it's too bright. But I can tell by using a Nikon camera, and with filters to be able to see the true side of the sun.
Hold on pretty quick. So for anybody that's watching at home, I recommend taking a screenshot of this website right here, because this is where he's going to be pulling my information for the presentation.
Yeah. So then the other way of finding out the data is through actual altitude and azimuth data of the sun or moon during one day. And that data comes from the data services from the Astronomical Applications Department of the U.S. Naval Observatory. There is the link. We'll get into that too. I'll show how I got the data for this information. But altitude, I'll just say it real quick here. Altitude means how high the sun and the moon is above the horizon. When those people that are on the north side of the sun or moon, we're going to see it rise, quote rise. It's really circuiting from basically our left to our right. And so it's basically going to go up in altitude from the horizon to the left, go up in the air in the afternoon, and at nighttime, the sunset's going to be to our right. Somebody looking from the south is going to be seeing it basically come from the right to the left, because they're on the other side of the celestial object. So All right. So visual observations of the sun and moon. When we visually see or observe the sun and moon in the sky, most of the day, they look to be the same size. So what I've done, I'm talking about this distance to diameter ratio. The first row of the sun and moon table below shows NASA's data, including their respective distance to diameter ratios. So I'm going to go on the first row for the sun. So you see it's 93 million miles in distance.
What NASA says, basically.
Right, this is NASA's data. And 870,000 miles in diameter. So if I divide 870,000 into 93 million, the distance to diameter ratio is 106.9. Now don't look at the rest of the rows yet. Let's go down to the moon's first row.
You want to explain what that means real quick? Just the ratios?
Yeah, that's what I said. When you divide the diameter into the miles of the Earth, it's taking that number, 870,000, divided into 93 million miles.
Yeah.
That means if you take 870,000 miles times 106.9, you're going to get 93 million miles.
Yeah.
Okay. So we do the same thing for the first row for the moon, the data that NASA says it is. The distance to the diameter ratio is 110.58. So what we're going to do, we're going to now shrink the distances, but keep the same ratio as we get closer to the Earth. So when you look at 100,000 miles for the sun, the diameter is 935 miles, and then 100,000 miles from the moon. Oh, wait a minute. They're getting closer in same size. 50,000, you're at 468, 50,000, 452. So just bring it on down all the way to maybe only 3,500 miles away. Sun is 33 miles in diameter, and then the moon is 32. So, hey,
that's pretty close.
It looks like they're the same size, like our eyes and my Nikon camera shows. So this is the basis for trying interpretation on this. But let's use geometry, triangulation, navigation, and astrometry to determine the actual distances of the sun and the moon from Earth and their sizes. So now we're
doing the scientific method, don't you?
Yeah, we're doing yes, we're going with logic, and starting from the beginning.
Testing what they say.
So here's just some definitions. Geometry is derived from the Greek word geo, which means earth, and metron, which means to measure. Triangulation is used for navigation and astrometry. Triangulation is based on the laws of plane trigonometry. Plane trigonometry means a straight line, which is a measurement of triangles. All sides of a triangle are always straight lines. The three interior angles of a triangle always totals to 180 degrees, I'm sorry. Navigation is derived from the Latin word navis, which means ship, and agere, which means to drive.
Wait, let me stop here quick. I forgot to say something in the beginning. So if we have time, if anybody has a question, then we'll try to do Q&A. So I'm not saying we will, I'm promising we will, but we'll try to if we have time.
Yeah, at the end. There's a lot of slides on this.
He has a pretty beefy presentation.
It keeps building up, so I'm trying to start from the beginning.
So just hang in there, and then we'll see if we get to some Q&A at the end.
And we're going back to geometry when we were in school, and a lot of people don't remember it. But this geometry is very easy to remember. Navigation is the science of directing a craft by determining its location, direction, destination, and distance traveled. Astrometry is a precise measurement of the positions and motions of celestial bodies, and that's what the U.S. Naval Observatory website gives to us. Throughout history, the navigators have developed tools to determine their location on the Earth by observing the positions and motions of the sun, moon, and stars by using triangulation. All navigation tools require a level surface and triangulation to determine the locations on the Earth and locations of celestial bodies. So we're going to start first off. The compass is an amazing navigation device. All navigation tools require a level surface to locate a position in a compass. So this compass, not all compasses have this, but they should. One that's very going to be accurate and trustworthy is it requires a compass needle to be level, to freely rotate to find magnetic north. And most of them should have a bubble level. So you can hold it in your hand and get it up, straight up. That allows the whole, in this case, if it's a needle or the surface of where it rotates to find magnetic north, it can move freely. So I don't know if you want to switch to this right now.
Yeah, so you can show it real quick.
Yeah.
He actually has one that's in the slide. It's a really cool compass.
So I don't know if I turn it up. Is it too much? See, right now I'm angling it, but I want to show you that it has a.
But we do have a video
it
that
has
something really
it has
cool.
a bubble on it, and so you keep it this, and when you rotate it around, it's always going to stay in the same spot for magnetic north. So we'll show a video that we did. If it, we're always on, everybody's living on a circular level plane, because anybody that uses a compass and they use it and they keep it level, no matter where they're on the earth, if they're at the equator, which apparently would be 90 degrees, angled from the top north in the globe model, north is at the top, and they would be doing this. They'd be doing this, and if they're down at
What about in Australia?
Antarctica, down here. So it has to be level, which means on the globe, it's got to be on the top of the globe to work. So we're going to do a video now, show this, what's going on.
And this is something that it was a team effort of me, George, and my lovely bride Candace. So that's a cool little video about how a compass works. So we used a beach ball to
represent
the globe.
Yeah. So the bottom line is anybody that uses a compass, wherever they're using it at, they're on a circular level plane. They're not on a globe, because it's the only way it's going to work.
As you will see in this video. So let's check it out real quick.
Okay.
Yeah, you want to walk them through what's going on?
Yeah. So right now we're on the top of the ball, the beach ball, and see, I'm rotating, trying to keep the bubble level, and you can see I'm moving the compass around, but the north stays exactly where it's magnetic north. Okay. Now we're going to start sliding down on the side, and you'll see the level bubble. The bubble's way off level, and I try to start turning it, but now everything turns, even the where the needle or it's not able to float anymore. So it's not worth anything. It's not telling me where you're at. Yeah, it's not maintaining the north arrow. So that tells you that there's no spherical Earth. And now we're going to switch down. We're going to show it where it's underneath, like it would be near the Australia area or even Antarctica. After this, we're walking it up, and you'll see eventually when we get up to the top, it'll move freely because we're getting it back to the level in the bubble. So now you can see it's maintaining its north position where magnetic north is.
And the level is level.
Yes. So now we're going to do it where we have the compass on the bottom.
Australia.
Yeah. So it's totally upside down. It's not going to do anything at all. The north arrow is just going to follow the whole compass around. There's no way to figure where you are. North can't show up because the whole compass is moving. It will not work. Now we're walking it back up. So now I guess we're coming up near the equator. And it's still not working. So this is a very, very easy proof that anybody using a compass, they're on a circular level plane.
And watch when we get to the top, it starts spinning.
Yeah.
Because it's not moving at all right now.
It's such an easy proof to show.
Boom, right there.
Right there. It gets back to where it's supposed to be, and you can use it as a true compass because it's freely turning to magnetic north.
And then Tyler made a good comment. He said, compass don't work on he's got a basketball, but it doesn't work on a globe.
Right.
So you're going to show the sextant now?
Well, we got to get back to the presentation. I'll show what the sextant looks like here. Okay. Oh, we just did.
Yeah, there you go.
Okay, so another prime navigation tool is a sextant that's been used for a long time. And it's a tool that measures the elevation or altitude above angular distances of the sun or moon and other celestial bodies, but it has to be used on a level horizon. You can see by this picture below. It's used to locate the navigator's latitude. We'll talk about that later on, but for positioning coordinates on the Earth, latitude and longitude are the two positions, and it's ground positioning, not global. So the figure shows how a sextant is used to measure altitude of the sun. The light travels from the sun to the index mirror, then it's reflected to the horizon mirror, and finally into the navigator's eyes. Simultaneously, the light travels from the horizon straight through the horizon mirror into the navigator's eye. I've got one, and I've actually, using the data from the U.S. Naval Observatory, a particular day and time, I went to the beach and I knew where my latitude and longitude was, and they told me what the altitude was, and I used the sextant, and it was right on for exactly what it said. So we're going to kind of show you, what the sextant looks like here.
And
so
he was.
This is it.
So I've seen him on YouTube, on videos. I've never seen him in
Right.
person. It was really cool. He was showing me
Right.
how it works earlier.
So the bottom mirror acts as a see-through mirror. So that's where you keep, being at the ocean is the best way to do this, because you can see the
You have the
water,
horizon
and the
right in
horizon
front of
goes
you.
forever
Yep.
with the level water. And then whenever you want to find your celestial body, it's the upper mirror. And basically, so you would go, like I said, I need to put this to 0, and then I'd be their level, and then it's going to move up. If you can see the mirror moving up, so it's going to locate where the sun is, and it's going to be actually the bottom of the sun or the moon is going to be right at the horizontal sea level line. Now these are for when you, if it's too bright with the sun, you bring them in to filter the sun, so you can still do it without hurting your eyes. But it's a very cool.
See the next day.
It's a very cool instrument, and being used for thousands of years, or years, quite a few
You
years.
just click right there and you'll put it back up.
Right here.
Yeah.
Okay. Well, I do it.
There you go.
Okay.
Yeah, there you go.
All right. Okay, and then the marine chronometer was used, and this was a key thing they needed to have for keep time. That was one of the biggest problems before they were able to do this and actually create a timepiece that would be very accurate, because they would know where they were on the latitude, but they didn't know what longitude. They could have been anywhere on the longitude line, and they didn't know. And a lot of times they had problems, shipwrecks and things like that. So this was created, sometime back, and it really was amazing for basically navigating on the seas. But this has a gimbal on it that's required to keep it in horizontal position, which means the accuracy of time by limiting the ship's movement due to wave action at sea. This is early on when they first started these things. So
was this invented before the sextant?
No, this came after.
Okay.
They actually, I think it was in Britain, the government was going to give whoever could create a timepiece that was accurate, they gave them a reward. It was a huge amount of money back in the day.
There's motivation to
Yep.
invent something.
They went to the private sector to figure the answer. Go figure.
Interesting.
So we're going to get into some trigonometric laws for basically navigating. The isosceles right triangle is basically a unique triangle where both the horizontal and vertical lines are of equal distance, and so it's a 90 degrees angle. So the other angles are 45, which means if you know you have a isosceles right triangle and you know the horizontal distance, you will know the vertical distance. So here we go. I'll just go through this. If we know,
let me say something real quick before you jump. So anybody that's against math, and you might feel like your brain's shutting down if you see that, just push through that.
Yeah.
I'm telling you, it'll be worth it. Just hang in there with us and do your best to try to track with George, because it'll be worth it. You'll have a better understanding how the sun and the moon work together than most people that walk this earth, if you can get what he's saying in this presentation. So just stick there with us. Stick in there with us.
Having to go back to basic, trigonometry. I just want to walk through this. If we know angle B, which is here, is 90 degrees and point C is above, the horizontal distance of AB is this line here, the horizontal distance, and angle A is 45 degrees, then we know the vertical distance of BC equals AB, and angle C is 45 degrees. So the bottom line is we have a triangle that's like this, but we know that the distance from B to A is the same as the distance from B to C. That's what you need to know. And this is called triangulation using trigonometry. All lines are straight and the horizontal distance is level on the horizon. Okay. So when we're going to do this, when we're going to use the navigation data from the U.S. Observatory, Naval Observatory, I'm going with double triangulation because if you look at this.
You want to explain the difference between single and double?
Well, this is it here. I got the single triangulation here with the arrow. And can they see the arrow okay? They tell us? Yeah, I think they can.
Can y'all see the arrow in the chat? Let us know.
Yeah. So this is actually the same thing that I showed on the previous slide, but now I'm using this horizon line as a longitude line. We'll talk about that later on, but that's a longitude line. And here's a latitude point. The latitude points go along the longitude line. And so this particular situation, I'm going north on the latitude line, AB. And I'm going to do the same thing on this side now, but I'm going south. But they're going to be the same distances on this triangulation and this one. The same isosceles right triangle.
So just for clarity for everybody at home, A is where you're at. Correct.
Yes. Eventually we're going to use, yes. But this is just basically triangulation to understand, distances. So now I'm putting together down here, double triangulation. So I'm just going to say right now real quickly. So we can say if we know that point B is 90 degrees up, and here's the sun or moon, and we know the distance going south on the latitude line is the same distance as the one going north
to the
horizon, then we know by triangulation, we're seeing this on both sides. They're going to do this angle, and that is going to meet there, and that's going to meet there. So we're verifying at 2 points now. We're getting double triangulation, which is very, very reliable. You can do it with a single because it's same information. We're just now doing on either side of a vertical 90 degrees point.
Yeah. So for everybody at home, so on the top is single triangulation, which is something you can do by yourself, but you'll need a second person. Like, so say you're at north. And then you have a second person saying, hey, I'm going to be out here at this time on this day. And you'll have the other person at the south at the horizon. So it takes two people for a double triangulation, correct?
Well, we're going to use the data from the U.S. Naval Observatory that tells us, we'll get to it.
Yeah, the confirmation.
We're going to get the data where we're at the south latitude point, where the latitude point B is, and where the north latitude point. And we'll be able to see that they're always going to be the same distance for the sun anyway. And we'll get to that. It's a slight difference between the sun and the moon because the moon's not as high as the sun, but we'll get there. So I wanted to explain a little bit about latitude and longitude lines on the Gleason's map and the globe map, comparing them, because most people, they hear it, but some people get it, I'm pretty sure. But I had to really understand this is part of my year study of navigation, learning how it goes. So what I want to do is for the Gleason's map, which is a circular level plane, I'm showing these latitude lines, which are the circles going around here and here. And they pretty much are based on the equator. The equator's in the center of the Gleason's map, but they're really circular lines that radiate out, and they're different latitude lines. And the latitude lines, like I said, they go along longitude lines, and the longitude is here. They're like the spokes going around, and longitude is time. Longitude is time.
Yeah, it looks like the little pieces of like a pizza.
Right, and you can see on this one, I think I added this to it on the Gleason's map. You can see 0, 1 through, it goes all the way for 24 hours. So that's the clock. It's a clock.
And it's also the time zones too.
Time zones, exactly. So, but latitude, so that's longitude lines are clock. Like where are you at time wise? Okay, that's what these radial spokes are. The latitude lines are actual distances in degrees, and we'll get to that a little bit later. Distances along the longitude lines, going from you know, from here all the way across. That's a longitude line, although it does change. We'll get into that information because it depends on if you're where you're going west or east on the longitude lines. So now let's look at the globe map, because this is a pretty simple picture. But latitude lines are pretty much horizontal lines that are going down around. But you can see there's a huge difference between these two because of how it's depicted. The longitude lines, again, those are timelines. The vertical lines are timelines. So, and you can see that, the longitude lines. And again, a latitude line on this, basically the latitudes. So if I do on this line, on a longitude line, the distance on this line is a latitude. So you see, because like, here's the equator. We'll get to, the equator is like 0 degrees. And if we go on this longitude line up, this is a 15-degree distance, a 30-degree distance, because you can see the degrees here. So that's actual distance on a longitude line. It's a latitude distance, and the latitude distance is in degrees, and we'll talk about that. So what I want to say here too is that when you look at the positioning coordinates, latitude and longitude, you'll see that basically whatever location you point, like at any city that you would look at on either map, the coordinates are going to be the same. For this system of the latitude and longitude as coordinates, it could be whatever shape, okay? But the key here is, we'll talk about it later, but they've got a different, we have basically a circular level plane, and then we have a sphere. They have the same coordinate system, and the same latitude and longitudes will be on each location, but obviously something had to be morphed on the globe one, because there you can see real quickly, here is the south ring, or circle for the Antarctica circle, but yet it's down to one single point here. So you can see they basically contorted immensely, the map. So I wanted to show this, because a lot of people, and in my first video about Earth's geometry, I went a lot into United Nations, because look at this map. Well, where did it come from? This map that they use is saying that they know that the Earth is a circular level plane, because they got it from the Gleason's map. It's a little bit oriented a little bit differently. There's
truth hidden in plain
there's
sight.
Australia right here, so they rotated it a little bit, but there it is. You can rotate. You got pretty much South America opposite from Australia, and it's the same way here. So that's the United Nations map is the Gleason's map, but yet they push the globe on it. So here's a little bit more detailed information about Earth's polar coordinate system for mapping, navigation, and astrometry. Latitude coordinates, and I talked about it. Earth's polar coordinate systems consist of latitude and longitude coordinates. The latitude coordinates are in degrees, with plus 90 degrees at north and minus degrees at south, and totaling 360 degrees. Now, this right here, this line is based on the it's really based on both, believe it or not, the circular level plane map, the Gleason's map, and the globe map, and hopefully you'll get the reaction, which took me a while. I'm trying to figure this out, and it finally came about. So again, there's north, and so it's plus 90 to minus 90. Okay, so the equator is 0. When you're going north, plus 45, and then 90. You're going north of the equator, minus 45, minus 90. Now, if you go on the other side, because there's actually, this is more a straight line, but it's also the longitude line. It's a straight line of the globe map and the straight line of the Gleason's map. So with the equator over here, again, you're going out 45 to minus 90. So minus 90 here on either side is going to be the Antarctic perimeter circle on the globe map, but then they wrap it around so they come together. The minus 90s come together as the South Pole, okay? And so what I want to say here now is that they're always located on latitude lines, coordinates are always located on a longitude line. So this line across here can be any longitude along the time spikes that we see, around the Earth. 1 degree of latitude, this is what comes off the Gleason map and also data for the globe map. This is the same for both. 1 degree of latitude on a longitude line equals 69.04677 miles. Okay. Therefore, all longitude lines are 24,856 miles in length. So what happens is when you look at minus 90 to plus 90, that's 180 degrees, then another plus 90 to minus 90. So we have 360 degrees that go from one south to the other south. And you can see that on the circular level plane because it's a long line, straight line. But what they did on the globe Earth is they did it from the North Pole all the way around the south and back. That's the same distance. So what you do is you take 69.04677 miles per degree times 360 degrees. That is basically the length of the longitude lines for both the circular level plane Gleason's map and the globe map. Okay? Very important. Very important. I hope people are getting it. So this is where the latitude coordinates are the same for the Gleason map and globe map. And this is a reference. Gleason's map state that there are 60 nautical miles to the degree. This is a little snapshot on the actual Gleason's map.
Yep.
Right here, it says English miles because corresponding to nautical miles, 60 miles to the degree. So we have to convert it because it's English miles. So 60 nautical miles equals 69.04677 English miles. Then we go again, 24,856 miles for the longitude line that's going across. For the globe
diameter.
Yes, the diameter of it, sorry. The globe map states also 60 nautical miles to the degree. So we go the same conversion. And here's basically the reference that I found on the website. Same thing, same thing. So longitude, we already mentioned that longitude coordinates are also in degrees, with 0 degrees at Greenwich meridian going west to minus 180 degrees and going to east plus 180 degrees, totaling 360 degrees. So longitude lines are time zones totaling 24 hours in one day. Each 15-degree longitude increment going east from Greenwich meridian is 1 hour later in time in relationship to Greenwich.
You want to for anybody that's not familiar with what Greenwich is?
Greenwich is basically a location in, I can bring it up, but they had an observatory right there. So they could have decided where they wanted to start 0 hour anywhere on the Earth, but since they had their observatory there, they did it. I can get back on the map and show you where that's at when we do this later, a little bit later. Then each 15-degree longitude increment going west from that location is 1 hour early in time relationship to Greenwich meridian. So again, back here is showing the coordinates going around.
Oops, I got ahead of you on this slide.
Yeah. So right here, it's a little bit out of focus, but that's the Greenwich meridian here. And it's right along that line. Over here on the other side is where the international date line is. And so what happens is most of the audience here is going to know that the sun is rotating around the Earth, not the other way around. So the sun's going clockwise here. When it comes around to this point here, it's the next day starting right there. Okay. So, and I've reiterated this too, the latitude and longitude coordinates for both maps.
So hold on, let me say something to somebody.
Okay.
Said something in the chat. So I'd recommend if you're watching this on the replay or the live, watch it maybe a second or third time to wrap your brain around it. Because somebody in the chat said, I'll need to watch it like 10 times to get it. So,
well, just stay with us, okay?
Yeah, and if you need to watch it again, because it's all good.
There's a couple other charts coming up real soon. It's hopefully going to be an aha for everyone, okay? Real quick.
And to tie it all together.
So the key here, all latitude and longitude coordinates for any location on the Earth are the same for both maps. Okay. So I talk about Earth shape. I'm referencing my first video called Earth Geometry, where basically I scientifically prove, that Earth is a circular level plane shown on the Gleason's map and the United Nations flag and emblem. All oceans are at sea level, contained by the perimeter Antarctic Circle. Commercial airlines use the Gleason map and United Nations flag and emblem for flight routes. That's the link to the YouTube and the Rumble episode. But we're going to still compare the globe Earth with a circular level plane in this relationship. Okay. So this is a lot on here, but what's important is I reiterate again, the longitude line is a line here, and that I reiterate that, and here I show it on over here, longitude line. This is the straight longitude line going across. The diameter of this circular level plane, Gleason's map, is 24,856 miles. Okay, because we're figured it out based on what the Gleason map says down below here about what.
If you don't have one at home already, buy one, please. Do yourself a favor.
So now these are all based on, again, it's basically geometry. Again, the length of the longitude line is 24,856 miles. I hope that number might be ringing in your mind now. If you know
most of them probably know that already.
What the circumference of the globe Earth is. Okay. So now what I'm doing is I'm getting some other data because the circumference of the Gleason map, you can do that through equations. This tells us that the circumference of the Gleason map is 78,887 miles. Then the surface area is 485,234,861 square miles. And the equator on this is in the middle, is the center, is half the diameter. Obviously, it has to be. It's half of the diameter. So it's 12,428 miles. But, we know that we're going to now talk about the globe. We're going to compare the globe. Okay. So this might be an aha moment for some people. Because again, the longitude line, which is the vertical line that wraps back around to north, that's same distance, 24,856 miles. So what I'm saying, when you look at this, the diameter of the globe, well, here it is, the circumference, the longitude circumference of 24,856 miles. So that goes from all the way around here. That's the same distance as the straight horizontal line as the Gleason's map, or the circular level plane. So now, and we know that, then we can go back and see, here it is. It's the total length of the longitude line is the same, 24,856 miles. But now it's the circumference of the globe Earth. So we take that circumference and basically realize that the diameter of the globe Earth is 7,912 miles. So, hey, you know what? That's what they did. They basically, with the Gleason's map, they took the diameter of the level plane of the Earth and wrapped it into a circle and made it the globe.
Yeah, hold on. Let me put a comment on there, which you'll appreciate. And we'll really get back to this later. But Ethereal Creation said, the Earth is way bigger than they tell us within the circle of Antarctica. And yes, I think George is really going to beat that point
so much bigger. Okay,
before we're done with this presentation.
So much bigger. So, this is a depiction, and this shows you that the longitude lines, which now are going, the vertical lines going all the way back around from north down to south, back up to north, is the same distance as what's on the Gleason map, going from one side of Antarctica to the other, the straight line. So now I'm going to compare, and this is pretty cool. I got to show the converting of the.
Yeah.
I got a video to show exactly what happened. I think a lot of people will have seen this before.
Well, I had to say that I was watching Terry Reicher's Flat Out Truth, and I first saw this on his channel, and I was like, "Oh, that makes so much sense," and it helped me understand. That same video helped me understand all the gates that Enoch was talking about as well. So let's check this video to see how they pulled the globe off.
Right. Yeah, so this has a couple of clips. That's basically Gleason's map, the circular level plane. You can see the latitude lines and the longitude lines, like spokes on a wheel coming out. You'll see what they did. This is what they did with the longitude lines. They made it basically a sphere. So it's just going to slowly change. That way you can see how they're basically going to pull down below all the longitude lines together. The latitude lines are staying the same, but the longitude lines are changing. It'll keep doing a little bit more.
So this is how the math works on both of them, basically.
Exactly. It's the longitude lines that are the same.
And here we have it. Voila, presto, changeo, their little magic
going.
trick.
Right. Right. One more. I'll go a little bit more. Okay, that's it.
Yeah, like that magic trick?
Yeah.
There you go.
All right. So this is comparisons between the Gleason's map and the globe map. Both these maps are now to scale relative to each other. So look at the difference. I mean, these are literally to scale. And I put the compass back on these maps to show you the compass works beautifully on the Gleason's map because it's a level circular plane. So basically, I have different sections here. Let's go down here at the bottom. The diameter of the Gleason's map is 24,856 miles. That's that line right there. Okay. Circumference of the Gleason's map. The reason I have this data is because it's going to show how much more surface area the Gleason's map has in the globe. Kept those on there. Let's go to the globe map. So again, look, these are the same. This is relative to each other. One of the things I want to show here is right there is the globe diameter of 7,912 miles on top of the circular level plane. It's so much smaller because even out here is the equator for the circular level plane. They just reduce it so much. And here's the data for the surface area on the globe map, which is a sphere map, right? So you can see it's only 196 million compared to 485 million. It's so much smaller. Surface area of the Gleason's map is 2.46 times larger than the globe map. The globe map reduces the Gleason map by 59%, almost 60%. So I wanted to, again, show, and I showed on here the South Arctic Circle going around, but compass works beautifully because it's on a circular level plane. It will always point toward the north because it's level.
Always keeps its orientation.
Always keeps its orientation. Globe map, I mean, you look, when we showed on that video, when you're down here, it's trying to go look through the earth. You can't do that. You can't do that. So this is, I hope people are going bing, bing, aha right now because it's amazing. This is another chart showing how the globe map reduces the Gleason's map surface area by 59%. So at the top, this would be the actual line, the true line of the longitude line, because it's going all the way across the diameter of the circular level plane, 24,856 miles. So now, though, this is what happens when basically when you start looking at these are the actual diameters now of other basically these are latitude lines on the globe. Okay, so what I did with those is these are the latitude lines of the globe, whereas these are the latitude lines going into the north, coming in, converging into the center north right here on the circular level plane. Okay, so again, you can see the equator here, which is half of the diameter of the overall diameter, is way out here, way beyond the Earth's equator here, and then on the other side over here, way beyond it. So what this shows quickly is all this hashed area is the reduced surface area of the circular level plane. It's tremendous.
So what we have in the circle is what it's really going on in all this is the shaded is what's not real. What they depict on the globe.
No. This is the globe.
Oh,
this is the globe Earth inside of it.
Oh, okay, I see
Okay,
that.
and this
Okay.
now is the surface area that was reduced by this fake globe
Stuff they're hiding. Okay.
that's on the circular level plane.
Got
Right.
it.
Right. So now let's talk about actual altitude and azimuth data of the sun and moon. Again, now we're going to be looking at the data services from the Astronomical Applications Department of the U.S. Naval Observatory. There's their access on the web. This provides altitude and azimuth data of the sun and moon for any day of any year at any location at time intervals down to 1 minute. You can go from 1 hour to 1 minute. And the data I got for all this, I did it 1 minute all the time. I mean, you know exactly every minute where that sun or moon is at. So altitude data is the angle of the sun or moon above the horizon is shown. And this, again, this would be anybody like it's north of the sun or moon because, you know, it, quote, rises in the east. It's actually just circling so we can see it.
Can I say something real quick?
Sure.
Yeah. So I wasn't familiar with this website, and he was showing it to me on his phone the last 2 or 3 days, and it's very precise. So this is proof that the sun is very consistent at any time,
Right.
anywhere on the earth, and you can check it
Right.
and confirm it's where it's at.
So so you have in both the sun or moon does this typically. It is almost like a triangle. When it's rising up, it goes up to a peak and then goes down because it's basically circling around us, and then it looks like it's rising first and then setting later on. So when you're here at the latitude longitude point looking at the sun or moon rising and going about, you can see different angles. Like here's a 15-degree altitude angle, then it's 30, and as it keeps going. So at some point, depending on where you're at, it very well could be 90 degrees up. And that would happen for the sun specifically anywhere between the tropics, the Tropic of Capricorn and Tropic of Cancer, because that's where the sun moves back and forth
on your location
for the seasons. Yeah. And then it goes back down. So we're going to be using the altitude angle as a key point to locate, you know, where the sun is and how far away we are altitude angle wise. So this is a very basic part of that triangulation we're going to do with an isosceles triangle. And I'm bringing this back again to remind us, okay, when we do these altitudes, we're looking at this altitude 45 to the sun and moon, and then one location that would be above it, and then again on the other side. So now we're going to get into the actual data part of this, okay? And this might look, you know, overwhelming.
Stick with us.
But so I'm going to bring it back down. So what I did this on purpose. I did 2 data points. We got a lot more because I got excited about showing what's going on with sun and moon at
Wait,
different,
you're geeking out?
different seasons. And then I did 1 lunar cycle, which is going to be very, very interesting later on. Very interesting. So on April 20th, this new moon occurred. So I gathered data for the sun and the moon, and basically, this is the data points I actually figured out and realized these are the true data points using the data for the sun and the moon. And what you'll end up seeing later on is these latitude and longitudes are very important, and there's a consistent distance between these numbers. We're going to show a video now of how I obtained the data from the U.S. Observatory, the U.S. Navy Observatory. Anybody can do this. It's just you got to be familiar with what you're seeing. But once you know what it is, the data is very easy to use. And I'll just tell you this: anytime you can find the location of the sun and the moon, anytime, any day, any year, any minute.
You're saying it's consistent?
It's consistent. And
so Abba put a perfect time clock in the sky?
Yes, it's intelligent design.
Yes.
So
totally. So this is this one?
That one, yeah.
All right, here we go.
So hopefully it won't go too fast when I talk to it, but I guess we can stop it if it does.
No worries.
Okay. All right. So
but if you need to, you can hit right there and hit stop.
Okay. So this is a website.
Or right there.
Right. And so it sun or moon in any day, azimuth, altitude and azimuth. And you can see, okay, so right now I'm picking the sun. It tells you the day. It's April 20th, and I'm going to tell it to do it once every minute. And now this is the latitude and longitude. I've already figured this out, but I'm putting it in anyway. Okay. So the latitude is 11.44, it's hard for me to read now because I'm looking on a smaller screen. It was 90. So now I have to tell it the time zone. So it's going to go east and it's going to have 6 hours. Now I can get the data. Okay. And so I'm going to click and get the data. And you'll see this tells you for this, it's for the sun for that day at that particular latitude and longitude. I'm just going to scroll down because I was trying to find where the sun is 90 degrees up on this longitude line. Okay. Where it was. It's going to tell me the time too. So there you go. It's 90 degrees up and there's the time of the day. So now I'm going to go back and keep the same longitude line because I'm going to go either north or south of it. Remember, latitude lines go up north or south on a longitude line. That's how distance is measured. So I change the latitude. I'm getting the data. And I scroll down. It's going to be the same time because it's on the same time longitude timeline, right? It's going to be the same time, but we'll see what the angle is.
So you're scrolling to the time of date.
Yeah, when he's on the same time of day, now you can see it's a 45-degree angle. I wish I could see it a little bit better than on the small screen here. Now I'm going to go another distance, and I'm actually going 45 degrees north or south of the location where it was 90 degrees. Okay. So it's going down for the same time. There it is. So I've just got three data points on the same longitude line. One that's showing the sun is 90 degrees and the north and south point saying that it's 45 degrees. And it happened to be a 45-degree difference in latitude north and south. Now I'm going to do it for the moon. The moon's, so I just got the data. I'm going to get the data for the moon. I'm going back to the latitudes that I've already determined right here. This first one will be basically the 90-degree angle, what latitude it is. And I'm going to go, and this tells you the fraction of illumination. Isn't that interesting? They say illumination instead of reflection.
For the moon?
Yeah, this is for the moon.
Because it is a luminary.
Right. That's interesting. Sunlight. So you can see there's no light on the moon, 0, 0 all the way down, because this is a new moon date. So now I found.
So you're looking at the moon now, not
the
sun.
Okay. Right. And so I got the data point for that. And now I'm going to do the next one. So I got the 90 degrees one on the data. And then I'm going to go, and the distance on this one, north or south, is actually 44.34 degrees. It's not 45 on the latitude line. It's a little bit less. But we'll see that it's still a 45-degree angle. It's a 45-degree angle right there, right next to the time. And then I'm going to go 44.34 degrees, the opposite direction on that longitude line. This is real data coming from the U.S. Navy Observatory.
And everybody can get on there and use it.
Yeah, you just got to understand, what's happening here, but hopefully it can happen.
Yeah.
Okay. So there's the other data point. Same time, it's telling me that's 45 degrees altitude angle. So we just got altitude information. Okay. So I think it's pretty much done now.
All right.
Okay.
Oh, there we go.
So now what I'm doing now, I'm going to compare both the Gleason's map and the globe map to the data. That this is for the sun's location for the new moon, and the data that we inputted, this is where it lays out on the maps. Okay. So let's go to the Gleason's map, basically, and you'll see the coordinate points are the same. That's what I was saying. The coordinate points are going to be the same because they use the same latitude and longitude points. So let's go with the sun here is at 11.44. This is where it's 90 degrees. So here it is right here, sun, 11.4 latitude. You can see it's kind of like in the ocean. So let's go over to the Gleason map. There it is here, pretty much similar location. It is the same location. And then we'll go to, which is basically going to be 45 degrees latitude north of 11.44. We'll show that later on, but you can see 11.44 plus 45 is 56.44. So we just moved up, and I'll stay on the globe map. We moved north 45 degrees to the next location on the longitude line. There it is, 56.44. It's somewhere in Russia. So we'll go over here on the Gleason. The reason it looked different is because the Gleason map I use is a different orientation, but it's the same location. And there it is. It's in Russia, 56.44 latitude. So that tells you, and then put the equator here so you can see there's the equator there. There's the 90-degree longitude line. Here's the 90-degree longitude line. So they're showing the same data and the locations. Now let's go to the table here. So I made this table. It's showing you, again, it's the same time, same longitude line, the latitudes that we looked at on that longitude line. 11.44, the altitude angle is 90, and then 45 degrees north, it's 45 degree altitude, 45 degrees south, 45 degree altitude. So you got to get into this calculation a little bit, but we know that latitude 11.44, the altitude angle of the sun is 90 degrees, which means the sun is directly over that latitude point. The horizontal distance between latitudes 56.44 to plus 44 is 45 degrees of latitude. So we got to go back. Remember we said it was 69.04677 miles per latitude? That's what we do here. We calculate 45 degrees of latitude on the map. It equals 3,107 miles. At latitude 56.44, the altitude angle of the sun is 45 degrees. That's the angle to see it. So we do the same thing. The horizontal distance between latitudes minus 33.56 to plus 11.44 is 45 degrees of latitude. So now we're doing the latitude distance between these two, which is 45 degrees of distance latitude. So do we do the same thing? We multiply the miles per latitude to 45, 69.04, whatever. We get the same distance. And we know at latitude minus 33.56, the altitude angle of the sun is 45 degrees. Now we have the data. Now we can use double triangulation to determine the elevation of the sun above the Earth using the Gleason's map and the globe map. So since we know that the globe map is a horizontal level line, pretty much surface, we have the same information. The sun at the new moon, April 20th at plus 90 degrees longitude, which is this horizontal line. This is the data. We had 45 degrees of latitude between 11.44 going south and going north. 45 degrees of latitude distance equals 3,107 miles either side. So by triangulation, we know that the vertical distance is the same. So the vertical distance of the sun from the sea level is 3,107 miles.
So this is on April 20th. Did you figure this out here in Myrtle Beach? Or was it from somewhere else?
No, it has to do with the longitude. I picked the longitude line, okay? Remember, any longitude line, any part of a day of a longitude line where the sun is crossing between the tropics, any point on the longitude line as it's going around like a time clock will be 90 degrees above that point at some point in time.
Yeah, sure.
Okay. So double triangulation proves the sun is 3,107 miles above sea level. Now let's try that on the Earth. We got the same data. Let's try it on the globe Earth. Here we go. So this is actually, this is a longitude line. This is the diameter of the globe. So this longitude line, we already said is 24,856 in distance. So this distance along this curve is exactly what is going to be plotted out here. So basically here's the equator. So this distance from here to here is the latitude distance to get to plus 11.44. So that's where the sun's 90 degrees. Okay, so it should be up here somewhere, right? But we went 45 degrees north. That's at the 45 degrees north on this line, which that line from here to, oh geez, how did I do that?
Here, I got you. Trying to go back.
There we go.
There you go.
Sorry, everybody, probably confusing them. So this point from here going up to there, the latitude lines is 3,107 miles. And now we have to basically create a horizon, like a tangent horizon there. We do the same thing here, going 45 degrees on the longitude line. So we do our 45 degrees because that's what the altitude angle was, right? We have to do it off the horizon on the globe. But look what happens. They're parallel lines. And this length here actually is the 3,107 miles. They don't triangulate at all. They're actually parallel to each other because of the 90 degrees curvature. You know, because you got 90 degrees and use a 45 degree angle, that altitude angle, they're always going to be parallel lines. I just got a feeling on this that Yah laughs at this because he did that on purpose. Anyway, there's no triangulation to the sun due to the 90 degree curvature of the globe Earth. It just throws the globe Earth away.
Never works.
Because I can always triangulate using this data. So I hope you all are following. I don't know if anybody's going offline because it's like, you know. So here's the data for the moon that we've seen. And we do the same thing. I'll talk on this one with the quote globe map first. So the moon is at latitude 11.52. Remember, this is a new moon. So a new moon, in this case, is showing us, wow, the moon is really close to the sun. If you look before, it was at 11.44. So they're extremely close to each other. And there's no light in the moon because it's a new moon. Just keep that data point. So here it is right here. And then I'll go north. This is the data point for north that basically is at 11.856 up here. And again, we're kind of up in Russia. And then you'll see there's a difference in the distance of latitude, which is, it's not 45, it's 44.34. Then we go from the moon down to south to minus 32.82. We'll do the same thing here. The moon is pretty much like, it's the same way, 11.52 latitude. We'll go basically north to the same latitude where it shows on the globe map, and then we'll go south into the ocean. So you can see basically that the points are on the same maps, but we're going to now switch to, look at that. Here is the data again, like I did before. You can see it's moon fraction limited 0. It's a new moon. This is the data. We're going to do the same thing where we talk about using the data we have to know what the triangulation is. So it's a little bit different. I'll go through this. It's similar to the sun, but we know at latitude 11.52, the altitude angle of the moon is 90 degrees, which means the moon is directly over that latitude point. The horizontal distance between latitudes 56.86 plus 56 to plus 11.52 is 44.34 degrees. So it's not the same. It's less than what the sun was. So now we got to put that in there. 44.34 degrees of latitude times the same miles per latitude. Now we're at 3,062 miles. It's like, oh, the moon's a little bit lower than the sun. At latitude 50 plus 55.86, the altitude angle of the moon is 45 degrees. We do the same thing for the other latitude point. Latitude minus 32.82 to plus 11.52 is 44.34 degrees of latitude. Again, we get the same distance, 3,062 miles. And at that latitude, that's a 45 degree angle. So we're going to do the same thing. We're going to triangulate. So here we are on the Gleason's map. Again, now for the sun, it was 44.45 degrees of latitude. For this one, where we've got it, those distances north or south of the 90 degree altitude is 44.34 degrees or 3,062 miles. So either north or south. You see that? That means by double triangulation, the moon is 3,062 miles above sea level. Double triangulation proves the moon is 3,062 miles above sea level. So,
Wait, wasn't that close to the distance of the sun?
Yeah, right. Gee, I wonder why we think it looks like the sun and moon are the same size.
Maybe because they are.
Right. So we'll do it again now on the globe map. Of course, this time it's the same, same thing. Globe map. There's equator, or plus 11.52, where the moon's supposed to be 90 degrees up. And then we go 44.34 degrees north and south. And then we got the 3,062 miles up and down. We do the 45-degree angle because that's what the data showed us on the horizon. And then here it is. It's looking this way. And that's the 3,062 miles, and there it is too. And they're not even close to each other. No triangulation on the moon due to the 88.68 degrees of curvature on the
So
solar.
it's less than 2 degrees than the sun because that was 90, right?
Right, because the latitude difference for the sun was 45 degrees from the 90-degree point instead of 44.34.
It's really close.
Yeah, but that's showing you that's why the moon is lower, because the distance is not as latitude distance is not as far when you get the triangulation going on.
Yeah.
It makes sense. It shows that. So the summary of this new moon tells you that really you don't need to look at the top of this, but one of the key things is the difference in elevations. Is that tells you that sun is 4 minutes ahead of the moon. They're very close because it's a new moon. And the distance between latitudes is very small. They're only 1.38 miles away from each other. So they're almost right on top of each other. The sun's almost right above it. The sun is 45 miles above the moon when you look at the difference in elevation. So they're so close, and the sun is 45 miles above the moon. And then, okay, we go back to that chart where we were looking at 3,500 miles above sea level. The sun was 32 and 30 miles in diameter. So it would make sense with those diameters that they still would be able to, they're not going to be hitting each other or anything like that. Sun and moon are 4 minutes apart from each other at that particular longitude. Sun is at 45 miles above the moon. Using NASA's data, distance to diameter ratios, and that's what we saw on the table. If I use those distances now, here you go. Sun at that elevation with that ratio is 29 miles in diameter. The moon at that elevation and that ratio is 28 miles. Sun and moon visually appear to be same size because guess what? They are.
And we'll see We'll see that in Enoch later.
And here's a picture, kind of an elevation picture of what's going on. View the sun and moon. On that time, new moon is a new moon. And here's the difference. This is a scaled look at the elevations between them, and they're the same size. So NASA tells us the reason the moon has no light during a new moon is because the moon is between the sun and the earth, and we were seeing a dark side of the moon. However, this is not true as shown. The moon is below the sun, yet not visible. This will be addressed later on. Okay. So I'm going to go through this other data quicker because you kind of see where I'm going and how to obtain the data. This is the same thing, but now I'm doing a full moon. Okay. I'm doing a full moon. And so, I'm not going to show how I got the data because I showed you the first time. It's the same process, okay? But what I'm going to do is basically show again on the different maps. So a full moon means that the sun and the moon are the farthest apart. We'll find that out. So here's the data. This is where the sun is at 16 plus 16.17 latitude. Number one shows it there. It's over here, 16.17. You can see it's the same location on the map. Second one is 45 degrees north, 61.17 latitude. And we're down here, 61.17 latitude, the same location on the maps. And then the one that's south is next to Australia, minus 28 in the ocean, 28.83 lat. And you can see that there, right there. Okay. So I'm going to go through this quickly. Again, it's the same calculation, we know. So we do this. So we know that every time the 45-degree north or south latitude is going to be a 45-degree angle to the sun. It happens all the time. So we'll just go to this again. And so here we go again. Double triangulation. We got the same miles, 45 degrees out. There's the 45-degree distance from the 90-degree viewpoint. And going south and north is 45 degrees of latitude, same distance, same vertical distance. It proves that the sun is 3,107 miles above the sea level. Then we do it on the globe map, the same thing. There's no triangulation because of the 90-degree curvature of the Earth. So these are consistent data. It never, ever, ever changes. Okay. Moon's location. Let's go that way. So this is the globe Earth. Now remember, the moon and the sun at a full moon are pretty much 180 degrees apart. They should be, because we'll find out later on that there's a relationship that moon that occurs. And you can visually see that as well with your own eye if you look for it. So sometimes you can see the sun going down, you'll see the moon come right up almost 180 degrees apart from it. So on the globe map, the moon is here at minus 14.15 on this longitude line of 80 minus 82.3. And then over here is right there, and that's the same longitude line. Then it's going south. South of there is down here, kind of near the tail of South America. And so there we are over here. There it is. And then we got, the positives, which is like somewhere in Florida, it looks like, see? And there we are, somewhere in Florida. So the points are the same. Here we go again with the moon. We know the moon is at 44.34 degrees of latitude. So it's always going to be this 3,062 miles. It's always going to be 45 miles below the elevation of the sun. And then we go to this, and here we see it. Same, here's a 90-degree point. We go south, 44.34 latitude miles, same distance. Go south or north rather, same distance. And then we have the vertical distance again, 3,062 miles above sea level. We have the thing again where there's no triangulation on the curve because it's 88.68 degrees of curvature. It doesn't change. So here's a summary of this. You can see the time difference here, longitude lines. There's 11 hour and 59 minutes of time difference, which is 12 hours, which makes sense. And so basically the difference between latitudes is that's what that is. But again, the sun is 45 miles above the moon. So here we go. We get the same information as far as the diameters of the sun and moon based on using the NASA's ratios for distance to diameter. And we get the same confirmation that they are the same size. So here's a picture of, I did this because of full moon, just to show you. That's where they are on the circular level plane. Moon is full illumination. Sun and moon are that far apart, 173.71 miles apart, pretty close to 180. Moon is fully lit when the sun and moon are the farthest away. So there is the moon that we plotted, and there is the sun. Again, we're getting consistent data. We're starting to see, oh, wait a minute, it looks like the sun is rotating around in the tropics, but we didn't know where the moon was because they want you to think the moon doesn't go in between each latitude. It's like, I tried to Google that too. I tried to Google online what's the latitude distances that the moon travels in, and you'll never get it because they don't want you to know it. They don't want you to know it. So here's an elevation of that full moon on the basically longitude line to give you an idea. These are pretty much to scale, and the sun and moon sizes, the scale. This shows you how small the sun and the moon are compared to the diameter of the Earth. When you look, that's a dot, and those are the elevations where they were at that time. And so it's very information that we keep seeing about the diameter of the Earth, the diameter of the sun, the diameter of the moon I rounded it to 30. We don't know exactly, but we know it's somewhere around there.
Yeah,
Because
this
of
is way different than what NASA tells us. Just insane
right.
distance and the
Right.
size of the sun and moon
Right.
are.
So there's a lot on here, just a summary of what was learned, the data that we got for the new moon and full moon. Double triangulation occurs when applying the latitude and longitude data to the Gleason's map, which is a circular level plane. We've proved it. And here's the same information. Double triangulation never occurs when applying the latitude and longitude data to the globe map, which is a sphere and curved surfaces. No convergence for the sun at 90 degrees curvature. No convergence for the moon at 88.68 degrees. Geometry, triangulation, navigation, and astrometry never work on a curved surface, but they do on the circular level plane. Okay? So again, you got to kind of look at this. What are the real sizes of the sun and moon? So what I did is I added the miles that we determined through the data, the actual miles that we know that the sun is above sea level. There it is. And then use the ratio. So it says 29. And then for the moon, 3,062, using that same ratio, it's 28 miles. But is there another way to observe and measure the size of the moon? Okay. All right. So I thought, well, I could create my own distance to diameter peep box. Okay. Oh, it's right here. I bought it. I got that. So let me just talk about, so some of these things. A distance diameter peep box can be used to determine the size of the sun or moon. The most accurate location to perform this is where the sun or moon are at 90 degrees altitude or straight up, because you'd be closer to it. But this requires the location to be within the north and south latitudes where the sun and moon are located, right? Because they're constantly moving around. And in my location right now, I'm in Myrtle Beach, so I'll never see the sun at 90 degrees. But it's coming our way now, because we're getting close to the summer solstice, but what I decided to do is I could create my own distance to diameter peep box and try to figure out from my location what the size is, to kind of give another verification. So you want to switch this real quick?
Yeah, so we can see it
better. Yeah. Boing. So that's what you see on the pictures. But so what I did is I wrote on there, the distance to diameter, the distance being 7 inches, and then the diameter I drilled a hole in this is 1/16 inch. So the distance to diameter ratio is 112 for this. But it took me at least one iteration to do it, because I had on the data using on the U.S. Navy observatory data, I knew the day when I wanted to do this, it was the next day. So the day before, I figured out where the sun is, and so what I did is, and you can see this here, that's the hole that I drilled.
Yeah, and I looked through it earlier. It's a really small hole.
And so what it does is, like it says on the thing, is I'm trying to create the distance diameter where when I look through the hole, and I use basically, you can say I use a filter. Well, we took that off, but I put a double filter on this so I wouldn't burn my eyes. And then I put it there and look through, and then it took a while because it's a small hole, but I got it. And I would wiggle it around to see if the sun was fully in the opening, the peephole. And the first time it wasn't. I could move it, and it was a little bit too wide. So that's what this little bump out was. So I added this bump out another 1/2 inch. And then when I did it on the day that I'm talking about here, it was right in the hole. I mean, it was right there. If I moved it any position, it would go right out of it. So it was like, wow, that's really, I got it.
It's a cheap experiment. It looks like $10 or less.
Less than that. So, and so you can see on the, you might want to switch back now. So I just had that information here showing the height, the distance, and all that. So, and this is, since the sun is moving toward the summer solstice, I performed this experiment, and that's what I found out was my ratio was, which is not too far off from what they show for the sun and moon from our friends NASA.
So you did this before the summer solstice?
Yeah, I did this. Yeah, I had to. This is the date I did it right here. Distance to sun using the peephole box, May 9th.
Okay.
May 9th. at that time because I had to do it at a certain time. So what I did, using the data off of the U.S. Navy Observatory, I found out right here where the sun was going to be 90 degrees up on my longitude line. My longitude line is minus 78.88. Okay. So I found out that data tells me that the sun altitude is 90 degrees at plus 17.42 latitude. And I know my latitude, right?
Yeah.
And the sun's elevation is 3,107 miles. So now I already know that distance, right? So I get to that latitude point. I know that. All I got to do now is get the distance from my latitude, which is 33.744. That's where I'm at here, where I was taking the reading. And to that latitude, which is 16.2474 degrees. So then I multiply that latitude distance by the degrees. My distance from that point is 1,124 miles north. So what I did from there, then I just plot, it's a triangle I'm creating right like that, 11,124 miles. And so now I know the distance. It's basically this distance here from where I'm at to the sun, which is 3,304 miles.
Because it wasn't directly overhead.
Right. I'm creating a different triangle, but I can still triangulate. Peak box distance to diameter ratio is 112. So then I take that and divide it 112 into that. I get a sun diameter of 29.5 miles. I thought, well, that's pretty cool. It's corroborating with what, bringing the distances down to what we know they are. And so this is another way which can confirm the sun's diameter is around 30, not quite sure, but it's easy to test, but it sure looks like
30-ish.
Yes. Yeah. I mean, I'm getting to a point where it's like, okay, I'm pretty sure, we got a sun that's a lot smaller than the Earth. So now I want to talk about the sun a little bit.
And I just want to say that he showed me this yesterday, and the slides on this and the moon are really cool if you can wrap your brain around what he's going to present.
So what I have a Nikon P1000 camera. So when I took all these pictures, I kept it always at 1,500 millimeter zoom, so they would look the same as we look at them on May 2nd. So what I was doing, I had them time stamped, May 2nd at 8 in the morning, 9, 10, 11, 15, 12, and then to 1. I got some more after this, but I don't know if you all can see it or not. Maybe it's not seeable, but first of all, I don't see any fireball coming out of this thing. It's
a lot gaseous.
So, and what I did here with my Nikon, I used a double filter. I mean, I have to do that because even the single filter makes it too bright. I don't want to hurt the camera. But so I don't know if y'all can see, but there are little pinholes here and here, that are on the sun. You can see it here, but what happens is over time, over each hour, you notice that those pinholes are rotating clockwise on the sun. You can see that little point there. You can see it coming down. Maybe we should look at that one because it seems to be right there. But these over here are moving clockwise.
But this will be easier, definitely easier to see on the moon side.
These are moving. So compared to the start point, it was up there and it's moving around. Now over here at 11 or X113, it's down. So now I'm going to go to some more. I had 3 more. Then we had it at basically 2, 4. But look, yeah. See, there's the spots now. See, it's way up here. It was over here starting in the morning. It's up here, and you can see the other spots. So it tells me that the sun's rotating for some reason. I don't know why. And the pinholes, I think they're not, what do they call them, sunspots? They're not sunspots. They're there, but they're just rotating for some reason. It might be a relationship with the moon. We're going to find out that the moon rotates clockwise too, as well in a minute. So their observations, the sun is light. Those are small, dark pinholes in the sun's light. But I noticed between 8 a.m. and 6:25 p.m., those dark pinholes rotate clockwise. There are no gaseous or gas explosions, reactions or explosion at all. The sun is not a gaseous fireball. Okay. Now we're going to look. So here I go. This is
And it might help on that last slide if you could watch it on like if you can connect it to like a Roku and watch it on a TV, you might be able to see what he was talking about.
right.
But you can see it right here with the
Yeah. So this I blew it up
picture.
more, so you can see those are the pinholes. And they typically, when it rotates, they're the same configuration. I noticed that pinhole there and these in here, but they're rotating clockwise. And this is from, this isn't electromagnetic light as proven by the Nikon camera.
Hey, you got my CGI image on here.
Yeah, there it is. It's not a gaseous fireball mass. It's just fake CGI pictures and videos. So, it's out and out clear. So I did this one, same zoom, 1500 millimeter for the moon on 2 days. The moon's, it was full moon, so I did that on purpose. So, what's that?
It's a question. Just save it for later.
Okay.
Unless you want to address it right now. You want to wait? Totally up to you.
Sunspot shame. Yeah, I don't think there's sunspots. I think those pinholes we'll talk about later.
Just for everybody. So one faith family said, question, could these sunspots be like windows, like Enoch said?
Oh, I don't call I would think that they're pinholes. They're not sunspots. I mean, that kind of talks about my thought is when we get to Enoch, we're talking about the relationship between the sun and the moon. There's an electromagnetic relationship going there, and it's very well those pinholes are basically ways that the energy goes to and from the moon and sun and the moon, back and forth.
Possibly.
It's,
That's a good question.
But I don't see, it's obviously a light. So those are there for some reason. And I think it might be the relationship between the sun and the moon and the type of light they have and how they work through a lunar cycle.
But this right here is a lot easier to see on the slide.
Yeah. So, I took these because with full moon, the moon's staying up really late. I was getting up with an alarm, different in the morning to take these. And May 4th at 4 o'clock in the morning. So the key here is, again, I think the characteristics of the moon here, they don't change. Whatever these dark, they don't. They're always the same. And what I always look for is these three right here: 1, 2, 3. And so it's at 4 and at 5 o'clock. It's a little bit down. And then I had to switch because it went down at just after 5 in the morning. It went, so I couldn't see it. And then this is the next little bit later in the day when it's coming up, basically at almost 8 o'clock. So 8 o'clock, those three are right there. And then basically, a little bit later, is that 8 o'clock? Yeah, that's 10 o'clock here. And then I missed it. I guess I slept too long. And at 3:30 in the morning, I woke up and go, oh. And so look how far the three are down now. I mean, it went, from up here to here. And then at 4:29, it's a little bit lower. So again, I'm seeing the moon rotate during time clockwise. So that's very interesting. So observations: if the full moon is bright and full of light, if the moon surface consists of a dark gray dust, dirt, and rocks, then the light from the sun would be absorbed by the dust, dirt, and rocks, and low or no light would be reflected. The moon has unique shapes of darker and lighter areas, which are always the same configuration. Between May 4th at 4 a.m. and May 5th at 4 a.m., these unique shapes of darker and lighter areas rotate together clockwise. And so I'm saying right here, these unique shapes of darker and lighter areas of the moon may be a result of an electromagnetic charging and discharging relationship with the sun. We know for sure that the moon is a light and is not a mass.
It's a luminary, like it's referred to as
Yes.
in Genesis chapter 1.
Yeah, we'll get to those later. But again, I'm trying to state stuff early, up front, scientifically, and show that stuff to somebody that's not doesn't know the Lord and doesn't believe in the God of the heavens and earth, So now I thought, well, let's try a relationship between the sun and the moon a little bit more. I'm still using the latitude, longitude, and altitude data from astronomical applications of the Naval Observatory to do this. So I'm going to look at the 4 season changes in 23, and then a full lunar cycle in September 23. So these are more, I'm just going to go to the point on these. So because we know based on the data before where the elevations are, these are showing me from the data where they're at on the particular, like the spring equinox, March 20th, 2023. So we know that in sun here, I made it sun in yellow and the moon in white, that based on the locations that are here, I plotted those out on the Gleason's map. And I highlighted the equator as red, Tropic of Cancer is green, and then the Tropic of Capricorn basically green as well. So we can know where they're at. And so we know that spring equinox means that the sun is moving north. So it's going to hit the equator, which it does right there. It's hitting the equator. And then the moon, that's the one thing we're going to find out from this data, that the moon actually goes farther south and north than the sun. I never knew that. Right there, you can actually see, here's the moon here, a little bit, west of the sun. And based on this data, the moon, and we know that at that time, March is getting close to a new moon. So there's almost a new moon, but the moon and the sun are about 20 minutes apart. So that kind of gives you an idea of what it looked like on the Gleason's map at that particular season, the spring equinox. So we're going to go to the summer solstice. So now we know the sun's going to be at the top of Cancer because it's farthest north, and sure enough, there it is over here, right there. And then you find out that the moon is pretty close. It's, a little bit east of it. Here would be the moon right here. So it's on longitude minus 79. And so, they're not quite quarter moon apart, but the sun is at the Tropic of Cancer, the moon is at the Tropic of Cancer, and they're about 3 hours apart. Okay. So we're seeing the sun, the sun's different places between these tropics, and there's somewhere going around here. So it's showing us, the sun is our clock, and it's constantly moving between the tropics, from the Tropic of Capricorn up to the Tropic of Cancer and back for a full year of sun moving as our clock. So the fall equinox, again, we'd expect this. The sun's going to be at the equator. Here it is over here. And it's at where it is, longitude 30.62, which is 30.62 is right there. And then we see that the moon is at longitude minus 123.90 over here. But look, oh my goodness, I didn't know this. And that was information I couldn't find out from Google. How far south does the moon's latitude goes? And now it's past the Tropic of Capricorn, which is farther than the sun goes. What I'm learning is the moon has different locations on latitude. It's a lot more sporadic where it's going than the sun. The sun is consistent, and the time clock. The moon latitudes are just crazy back and forth.
Sort of wonky.
Well, and so the moon is south of the Tropic of Capricorn, and the moon and sun are about 10 hours apart. So let's go to the winter one. And then the winter one, you got the sun because it's supposed to be down there south on the Tropic of Capricorn, which it is. And it's basically minus 78.70 degrees longitude. The moon is right here. It's at plus 38.229 longitude, but its latitude is closer at the time. Sun is at the Tropic of Capricorn, and the moon is north of the equator. They're about 8 hours apart. So that kind of gives us an idea of that. We can see the relationship between the two. The sun is consistent. The moon basically is sporadic as far as what latitude line it's on. So I decided to do a moon cycle for September 23rd. So I did basically a new moon, which means they're going to be right next to each other. and it's coming up later this year. But you can see sun and moon are extremely close to each other, extremely close, similar to what we saw in April 20th new moon, right next to each other.
So that'd be right before the equinox, because it's on the 14th.
Yes. So they are right to each other. The moon has zero luminance. Sun and moon are about 3 minutes apart. And again, the sun is 45 miles above the moon, which will always be. So we'll do the quarter moon, which means what's happening is the sun's past the moon and it's getting farther away from it. And we can see that. So we observe basically the sun's over here and basically at longitude minus 78.81. Moon's over here because we know the sun's faster. It's gonna lap it. Sun laps the moon once every 29.5 days. That's how the lunar cycle is. So the moon is at plus 13.44 longitude. And basically the moon is south of the Tropic of Capricorn. Again, it's farther south than the sun ever gets. Moon and sun are almost 6 hours apart, which would be a quarter moon. 6 hours apart, it's a quarter moon. And by the way, the light of the moon is always facing toward the sun. That's another relationship. When it's building its light up, it's always facing where the sun is. When the sun passes it, the light of the moon is looking toward the sun wherever it's at. And the moon is 50% illuminated. We can see that right here. The moon illuminates 0.52. Makes sense. That's what we see. Illuminated part of the sun faces the moon. Okay. So now we're going to be at a full moon later on. And so here's the sun over here. It's on longitude minus 149.98, on latitude minus 2.58. So it's very close to the equator. And the moon's over here at longitude plus 21.96. And it's at latitude minus 2.7. So they're both at this time kind of close to the equator.
Mm-hmm.
So the sun and moon are farthest away from each other. Sun and moon are almost 12 hours apart. The moon is full of illuminated light. So right there, it's 100%. So you can see, that time difference here, it's almost 12 hours of difference, which tells us that's the relationship with the sun and the moon. They're doing electromagnetic charging fully right now for the moon. Third quarter, and then that means the sun's going to start getting closer to the moon now because it's getting ready to lap it. And the sun is here, which is at plus 10.32 longitude, and it's minus 5.2 degrees latitude, a little bit south of the equator. The moon's over here at minus 78.8 longitude, and it's located at plus 28.04 latitude. So again, it's farther outside the Tropic of Capricorn. Didn't know that. Again, the moon is south of the Tropic of Capricorn. Moon and sun are almost 6 hours apart. The moon is pretty much at 50% illuminated. The illuminated part of the sun is facing the sun, and the moon is facing the sun there too. So that gives us an idea that we're seeing, relationships there. So let's go farther with it. A lunar cycle occurs on average once every 29.5 days, which is the same time it takes the sun to lap the moon, one lap. New moon, start of the lunar cycle, sun and moon are close together, moon has no light. First quarter moon, 7 days into the lunar cycle. Sun is 90 degrees west of the moon. Moon is 50% lit with the lit side facing the sun. Full moon, 15 days into the lunar cycle. Sun is 180 degrees from the moon. Farthest away, moon is 100% lit. Third quarter moon, 21 days into this lunar cycle. Sun is 90 degrees east of the moon. Moon is 50% lit with the lit side facing the sun. The new moon, day 29.5 of the lunar cycle. Sun lapped the moon. Lunar cycle is complete. So here's a relationship that I'm going to talk about. Enoch here. As stated in 1 Enoch and Jubilees, 364 days is 1 year and is kept by the sun. You want to read some of this, Matt? You good? You want me to read it?
Yeah, I'll jump in later and read it.
Okay, all right. I'll just read. The first Enoch chapter 78 states the duration of a lunar monthly lunar cycle is 30 days and 6 months of the year and 29 days and 6 months of the year, averaging 29.5 days for the months. And here you go. For 3 months, its proper time, it achieves 30 days. And for 3 months, it achieves 29 days, during which it completes its waning. And in the time of its rising, for 3 months, it appears each month with 30 days. And for 3 months, it appears in each month with 29 days. In 1 year, the moon circles the earth 354 days. 29.5 days times 12 lunar cycles equals 354 days, which is 10 days less, and stated in First Enoch chapter 79.
Yeah, let me jump in right here and say something. So all this research that you compiled with this presentation, to me, this is another confirmation that shows that we should consider First Enoch and Jubilees as scripture, because you see right here in chapter 79, it's talking about the moon is 10 days short. And if you flip over to Jubilees 6, you see the same thing. Right. And every 3 years, you have the issue of the extra 30 days. So you have to have a 13th month for anybody that does a scriptural feast. So this is another confirmation to me after looking at this and what he's presenting. So it's very awesome and interesting.
And by the way, I actually found, I was Googling information from what NASA says, right? I actually got this. I took a screenshot of it, but this is what NASA says. The moon displays phases one after the other as it moves through its cycle each month. It takes about 27.3 days for the moon to orbit the Earth. Okay, we know that's not right. However, because of how the sunlight hits the moon, it takes about 29.5 days to go from one new moon to the next new moon. It's like, they're actually admitting it. And it's like, wow, I thought I would never find that, but I did. So then I thought, you know what? Let me take, because anybody can do this too. You can get the lunar cycle for 2023, and that you can count the days. There we go. This comes right off of the website that talks about the lunar
somebody
cycle.
Just mentioned time and date in the actual chat, so that's cool. You have a slide for it.
Yep. Right. So what I did is I counted, because you have to count and really literally each day. And I did have to overlap, I think, a little bit going into 2024 to get the final numbers for December, the last month. But how this works is, I'm looking at basically this is the cycle for January. So for that week, 7 days, this is a cycle, 7, 7, 8, 8, 30 days for that cycle. Okay. For this February 1, it was 7, 7, 8, 7. So it was 29. For third month, 7, 7, 9, 7. Thought that was interesting when I was doing it. 30. For the fourth month, 7, 7, 8, 7. 29. For the fifth one, 7, 8, 7, 7. 29. 6 month, 8, 8, 7, 6. 29. And 8, 8, 7, 7, 30. Then the eighth one, 8, 8, 6, 7, 29. The ninth lunar cycle, 8, 8, 7, 7 is 30. Then 10th, 8, 7, 7, 8, 30. And 11th, 8, 7, 7, 8, 30. And then the final one, 7, 7, 7, 8, 29. So if you look on here, 1, 2, 3, 4. There's 6 months of 30 and 6 months of 29.
Yeah.
Equals 354 days, 29.5 days per lunar cycle.
Confirmation.
So it's a confirmation of it actually being there. So we get into the electromagnetic relationship between the sun and the moon. Sun and moon are plasma, and the sun electromagnetically charges the moon's plasma to cause the moon to light up. As the sun moves farther away from the moon's plasma, the moon continues to be charged by the sun, resulting in the moon having more light. When the moon is fully charged, it's lit full moon. During a full moon, the sun and moon are farthest away from each other, 180 degrees apart. As the sun moves closer to the moon's plasma electromagnetically discharges to the sun, resulting in the moon having lesser light. When the moon is fully discharged, the moon has no light. It's a new moon. During a new moon, the sun and moon are closer to each other that we've seen. This cycle of the sun electronically charging the moon and the moon electronically discharging back to the sun is consistent. So this is interesting. Any portion of the moon that is lit that we see, any portion of the moon that is lit, we see what looks like craters, which are caused what I believe is electromagnetic charges in the moon's plasma transferring back and forth between the sun and the moon. These craters are always circular in nature, which would be caused by electromagnetic charges hitting the moon's plasma surface. If the craters were caused by space debris colliding on the surface of the moon, we would see many different types of geometric impacts, like linear or oblong impacts with mounds of debris on the sides of the impacts, or mounds of debris where the impacts came to rest. We don't see any of this. So let's get to the physical relationship between the sun and the moon. We're repeating some things here. Sun is around 30 miles in diameter. Its elevation is 3,100 miles above the sea level. Moon is also 300 miles in diameter. Its elevation is always 3,062 miles above sea level. The moon is always 45 miles below the sun. Sun and moon can never align to block or hide the view of each other. So solar eclipses can never happen, and lunar eclipses can never happen. New moons are never between the sun and the earth. New moons have no light.
Okay, let me give a disclaimer on this slide. So this right here is new to me. So I'm gonna just err on the side of caution here and say I'm not sure that this is where George is coming from, and this is where he has arrived with his research. So I'm just gonna throw a disclaimer in there. I'm not sure on this myself because I haven't dug deep as him, but just throw it out there and you can take it or receive it, just like anything I present on any of these presentations. So
there's no dark side of the moon. The moon is a light.
I was thinking about the dark side earlier.
So I want to, just in perspective, the Earth's diameter is 820 times larger than the sun and the moon. NASA tells us that the sun is 110 times larger than the Earth. It's just so extremely backwards and it's a huge lie. So I want to give a perspective, because the other pictures of a circular Earth, I wasn't showing the true size of the sun and moon. On this one, it is. So
it looks so small.
Yeah, I don't know if you all can see it, but I've got it arrowed here with the sun being yellow and the moon being white. But just look, the real size of comparing the size of the sun and the moon to the diameter of the Earth. There's no way that the Earth is going around the sun with this. The sun is going around. It's physically impossible.
Scale, that's crazy.
It is the scale
between the two.
It is, because like we said, it's 69 miles per degree latitude. Well, the sun and the moon are only 30. They're not even a half a degree of latitude. Not even a half a degree. So we could go here again. Almighty God's word tells us 1 year is 364 days in Jubilees in First Enoch. Jubilee 6:30 to 33. And all the days of the commandment will be 250 weeks of days, and these will make the entire year complete. This is engraven and ordained in the heavenly tablets. There is no neglecting this commandment for a single year or from year to year. And command thou the children of Israel that they observe the years according to this reckoning, 364 days. And these will constitute a complete year, and they will not disturb its times from its days and from its feasts, for everything will fall out in them according to their testimony, and they will not leave out any day nor disturb any feasts. Enoch 1:82-6. For they belong in the reckoning of the year and are truly recorded forever. One in the first gate, and one in the third gate, one in the fourth gate, one in the sixth gate, and the year is complete in 364 days. Enoch 1:82-11. There are 4 leaders who divide the 4 parts of the year appear first, and after them the 12 leaders, the orders, who divide the months and the years into 364 days, with the heads over thousands who separate the days. And for the 4 days that are added to them, there are the leaders who separate the 4 parts of the year.
Yeah, let me say something about these couple scriptures. So this is what I was hinting at earlier when I was talking about Jubilee 6 and the 10-day difference between a lunar year and a solar year, and all this research that George has compiled to prove Jubilee 6 and Enoch 82. So if you haven't read First Enoch and you really want to understand how the luminaries work, I highly recommend reading chapters 72 to 82 and take your time because it's very meaty. Just ask the Most High to give you understanding. It will really help you understand His creation a lot better. I guess I can read a little bit.
Okay.
So here are some scriptures that state the sun and the moon are lights or luminaries, which tells us the sun is not a gaseous fireball, which I jokingly said earlier, and the moon is not a mass. So Genesis 1, which I referenced earlier, 14 and 19. Then Elohim said, "Let there be lights in the firmament of the heavens to divide the day from the night, and let them be for signs and seasons, and for days and years, and let them be for lights in the firmament of the heavens to give light on the earth." And it was so. And Elohim made two great lights, the greater light to rule the day, the lesser light to rule the night, and he made the stars also. We shouldn't discount the stars. They play their roles well, just like the sun and moon. Elohim set them in the firmament of the heavens to give light on the earth and to rule over the day and over the night, to divide the light from the darkness. And Elohim saw that it was good. So evening and morning was the fourth day. Isaiah 13:10. For the stars of heaven and their constellations will not give their light. The sun will be darkened in its going forth, and the moon will not cause its light to shine. And then, 27 chapters later, Isaiah 30:26. Moreover, the light of the moon will be as the light of the sun, and the light of the sun will be sevenfold as the light of 7 days, and the day that Yahweh binds up the bruise of his people and heals the stroke of their wound.
So in continuing, Isaiah 60:19, the sun shall no longer be your light by day, nor for brightness shall the moon give light to you, but the Lord will be you an everlasting light, and your God your glory. Jeremiah 31:35, thus says the Lord, who gives the sun for light by day, the ordinance of the moon and the stars for a light by night, who disturbs the sea and its waves roar. The Lord of hosts is his name. Ezekiel 32:7, when I put out your light, I will cover the heavens and make its stars dark. I will cover the sun with a cloud, and the moon shall not give her light. Matthew 24:29. Immediately after the tribulation of those days, the sun will be darkened and the moon will not give its light.
Will not give its light. That means it's a luminary, according to Scripture. Regardless of what NASA says, it reflects the sun's light. So that if you're going to accept Scripture as Scripture, you're going to have to throw some of the stuff that NASA throws. Some of the stuff that NASA says, you got to throw it in the trash can, or you can't read stuff like this and consider it Scripture.
The stars will fall from heaven, the powers of the heavens will be shaken. Mark 13:24. But in those days after the tribulation, the sun will be darkened and the moon will not give its light. So we're going to talk real quickly. First Enoch chapter 28 talks about the electromagnetic relationship between the sun and the moon.
You mean 78?
78. Chapter 78. The moon's lunar cycle of new first quarter full and third quarter moon is described in First Enoch 78:10-14. And Uriel showed me another law when light is transferred to the moon and on which side it is transferred from the sun. So it tells us that when whatever side the moon as its light is coming from the sun. First Enoch 78:11. At the time that the moon is increasing in its light, it transfers as it becomes opposite the sun until in 14 days its light's full in the sky. And when it is all ablaze, its light is full in the sky. And on the side on which the light of the moon appears, there again it wanes until all its light disappears and the days of the moon end and the disk remains empty without light. Enoch 78:12. And on the first day it is called the new moon, on that day daylight rises in it. 78:13. And its light becomes full exactly on the day that as the sun goes down in the west, it rises from the east for the night, and the moon shines for the whole night until the sun rises opposite, and the moon is seen opposite the sun. 14. And on the side in which the light of the moon appears, there again it wanes until all its light disappears, and the days of the moon end, and its disk remains empty without light. So,
me.
Okay.
Enoch 72:35. So this is showing that sun and moon are the same size. This is the law and the journey of the sun, its return as often as it returns. 60 times it returns and rises. That is the great eternal light, which forever and ever is named the sun. Next verse, 36. And this that rises is the great light, which is named after its appearance, as Yahweh commanded. 37. And thus it rises and sets. It neither decreases nor rests, but runs day and night in its chariot. And its light is 7 times brighter than that of the moon, but it is in size, the two are equal.
Right.
And then we see the same thing, which Tyler posted this scripture in the chat earlier, chapter 78, verse 3. These are the two great lights. Their disk is like the disk of heaven, and in size, the two are equal.
Yeah. So let me talk about sunbeams a little bit. Sunbeams prove that the sun is close to Earth. This is a really good picture I just happened to find earlier today. It shows the rays. So we observe this occurrence with the sun very often. Sunbeams passing through cloud openings we see are angled beams of light, which can only occur if the sun is close, which it is. It's very close. A sun a million miles away from the Earth would result in parallel beams of light, which we would never observe. So, but I want to say, I found this out today too. The lie Wikipedia and NASAites want you to believe. This is what I got from Wikipedia. A sunbeam in a meteorological optics is a beam of light, sunlight, that appears to radiate from the position of the sun, shining through openings in clouds. These beams of particle scattered sunlight are essentially parallel shafts separated by dark shadow volumes. Their apparent conversion in the sky is a visual illusion from linear perspective. The same illusion occurs, I'll try to equate it, the same illusion that causes the apparent convergence of parallel lines on a long straight road or hallway at a distant vanishing point. You know, that is such a huge lie. And basically what this tells you is don't let anyone ever teach, explain, or tell you what you observe with your own eyes. You make your own decisions on what you are observing with your own eyes.
Yeah, can I jump in there real quick?
Yep.
We'll go back to that. There we go. Okay. Yeah, so this is an awesome picture. So he's talking about the sunbeams, which these are in the scientific community, these are labeled as crepuscular rays or anti-crepuscular rays. So whenever you talk to somebody about the distance to the sun, most people, if you ask them like, hey, what does science say the distance to the sun is? And most will not be able to answer 93 million miles. And so if these sun rays, you can pull this up and show a picture and say, what you're seeing proves it's impossible for that distance, because you see these converging to something up in the sky, which is the sun. You can't see it in the picture, but it's behind the clouds.
Right.
And so the only possibility at that distance, 93 million miles, is parallel rays. What you're seeing on the screen is impossible, but it's reality every day.
Yep. Okay, so misspelling there, it's okay. So this is a summary again of what's going on. We got a little bit more information that the Earth is a circular level plane, is 24,856 miles in diameter. Sun and the moon are the same size and around 30 miles in diameter. Sun's elevation is always 3,017 miles above sea level, and the moon's elevation is always 3,062 miles above sea level. Earth's diameter is 820 times larger than the sun's and moon's diameters, or stated another way, sun and moon are only 0.12% the size of the Earth. It is physically impossible for the Earth to rotate around the sun. The Earth is fixed and non-rotating. The sun is the Earth's time clock and circles clockwise around the Earth 24 hours a day every year between minus 23.4 and plus 23.4 latitudes. And then we have basically the seasons here, the different latitudes, how it's traveling. The moon circles clockwise around the Earth slower than the sun, which causes a 29.5-day lunar cycle, and found out that it goes between plus 28 and minus 28 degrees latitude. That's a new one. Didn't know that. So some quick conclusions. We've kind of talked about this over and over again, but it's basically telling us things that we hear from NASA and the world is false. So I want to talk real quick about the rotating Earth impossibility, because we go back to the globe. Earth's latitude surface speeds due to rotation, quote rotation. So what this picture shows is a lot of people don't realize how fast the Earth is supposed to spin, in a 24-hour period. So this shows you wherever latitude you're at, which equator is the widest diameter. So this shows you that in order for the Earth to spin one revolution in a day, it's 1,035 miles per hour. And then you can see when you go close north and south, you're spinning on top, right? So you can see even, when you go to 15 or 30, even down to 60 degrees, you're still at 518 miles per hour rotation, So you're, look at the, So what I want to say is that counterclockwise rotation speeds range from, just went from 518 to 1,035 miles per hour. Well, the speed of sound is 746 miles per hour. So, quite a bit of the Earth is rotating faster than the speed of sound. And commercial airlines cruise at around 550 miles per hour. So if that's the case, no life structures or trees would exist on the Earth due to the surface wind shear of 518 to 1,035 miles per hour. We get all crazy about with the weather coming, and we get hurricanes that, go to extreme levels of wind. But, they're between 74 and 185 miles per hour, which are extremely low compared to the wind speed of a rotating Earth, So we have to think about this, as an architect, we have to design structures for wind shear. And, we conform to the wind requirements in the building codes. But however, if life structures and trees do exist, I missed something here. Yeah. Oh, I'm saying this, that if life structures and trees do exist, so on the Earth, and the Earth is rotating at these speeds, then the air on the surface of the Earth must be moving with the Earth between 518 to 1,035 miles per hour. In other words, the wind needs to be going, the air needs to be going in the same speed, counterclockwise direction as the rotation of the Earth, so we have none of this wind shear, right? It's got to be going with the Earth, so we don't feel it. I would call this, if that's the case, this would be called Earth's west to east background surface airspeed. But no one ever describes this phenomenon. We don't hear it from the weather channels, like say the weather today, we got a wind going east, but against the background speed of 1,035 miles. You never hear it ever. And you don't hear it from the airline pilots, we have our background wind speed of 800 miles per hour. We're having to deal with whatever,
Yeah, how would they deal with that?
Yes,
kind of speed when they land.
So this background surface air speed between 518 to 1,035 miles per hour is always blowing west to east, would prevent the following actions, which always occurs and we always observe. Days when the air is totally calm or still, and then a slight breeze swirls to the west, opposite the background speed of the air, supposedly, or going in any direction in just a few seconds. We see that all the time. We get swirling winds. We got winds that go back and forth. And so that would never happen, but it happens all the time because the Earth is not moving. It would never happen with a background wind speed of this going around. And then the commercial airlines flying northwest or southwest at a speed of 550 miles per hour, they reach their westerly destinations. They wouldn't reach their westerly destinations if they had that wind going against them because their planes go too slow. Therefore, the wind is fixed, the Earth is fixed and non-rotating, and we now see even more reason why. The sun is so much smaller than the Earth, so the sun has to be rotating, and it's our time clock. And it's the Earth's the Earth's only sun. It doesn't do anything else other than that.
You're saying geocentric, not heliocentric.
Yes, exactly. So here's some scriptures about the Earth is unmovable, cannot be moved, and is fixed.
I guess I'll do these.
All right.
You've been doing a lot of talking.
Yeah. Thanks. Let me get a drink.
Yeah, there you go. 1 Chronicles 16:30. Tremble for him, all the earth. The word also is firmly established. It shall not be moved. Psalms 9:31, one of my favorites. Yahweh reigns. He is clothed with majesty. Yahweh is clothed. He has girded himself with strength. Surely the world is established so that it cannot be moved. 96:10. Say among the nations, Yahweh reigns. The world also is firmly established. It shall not be moved. He shall judge the peoples righteously. Psalms 104:5. We get a lot of truth about creation in Psalms. You who laid the foundations of the earth so that it should not be moved forever. Like some versions say, it doesn't totter. And then 1 Samuel 2:8. He raises the poor from the dust and lifts the beggar from the ash heap to set them among princes and make them inherit the throne of glory. For the pillars of the earth are Yahweh's, and he has set them, the word upon them. Is this the King James? Thought the scriptures?
Probably New
Okay.
King James.
Yeah, just curious.
So I'm going to jump into the Earth's air because, we're now saying some things that people, most of the world would go, no, there's no way that the sun's that close and all that. So I wanted to talk about the Earth's air because we have to talk about the heavens and the earth, So Earth's air primarily consists of two gases, which are 78% nitrogen and 20.9% oxygen at sea level. The air pressure at sea level is 14.7 psi, pounds per square inch. Sea level is the perfect elevation for the human body to live due to the highest concentration of oxygen at 20.9% in the air. The higher the elevation above sea level, the less dense the air becomes, and the oxygen concentration in the air is reduced. So I just kind of had this right here, where when you're at certain elevations, how the air pressure is reduced and the oxygen concentration. So, when we're at zero, again, that's perfect. We're getting as much oxygen to our body as possible. That's how we designed it. At 500 feet above, it's still really good. And so when you look at the other elevations, 5,000 feet, I've been in Denver and tried to do a workout one night, and I was hurting, man. I was hurting because I didn't get used to it. But that was, only a 2%, maybe a 3% reduction in oxygen, but I noticed it. So when you go to these other elevations,
Let me share too, since you're talking about this. So I went on a mountain biking trip with my uncle and cousin. It's like how many years ago? A couple years ago, and we were at 10,000, sometimes 12,000. At times, after a few miles, me and my uncle were like, because the air is just so thin up there. It's wild.
Yeah. So when you start getting up to altitude 60,000 feet, there's no oxygen at that level. So obviously nobody can breathe. And I think at that feet is pretty much where you have to have a pressure suit if you're a pilot, because you have to have a pressure at that elevation. Fluids coming outside the body will actually boil. So they have to put a pressurized suit to get the pressure back up. But so we're going to talk about air's oxygen concentration limits altitudes where humans can live. Safe oxygen levels for humans to sustain normal functions. The percentage of oxygen is to sustain life according to OSHA, which is is between 19.5% and 23.5. So obviously the oxygen at sea level is right near the 19% and a half, but not enough oxygen side effects. Oxygen concentrations from 19.5 to 16%.
Bunch of bad stuff.
Causes the body cells to fail to receive oxygen needed to function correctly while doing physical activities. Oxygen concentrations from 14 to 10% result in impaired mental functions, intermittent respiration, and body exhaustion at any amount of physical activity. Humans won't survive with oxygen levels 6% or lower. So I found this out. I kind of did some research. Most of the world's population lives on coastal plains with altitudes of 500 feet or less.
What's the percentage? Like close to 90%?
About 90%.
That's crazy.
Yep. Where oxygen concentrations are safe and healthy levels between 20.9% and 19.6. So it's perfect. And the reason for this, rivers are a perennial source of water for drinking, bathing, and farm irrigation. Landed rivers are fertile for growing crops and raising farm animals. Rivers provide transportation routes for selling goods. So there's a lot, those rivers are a lot into the coastal plain areas. There are people like in Tibet who live at elevations of 17,500 feet. But above this elevation, the climate becomes too cold for growing crops, and there's not enough oxygen in the air to sustain human life.
And they live there their whole life, so their body acclimates to the environment.
Yep. So Earth's sky, how high? The higher the elevation above sea level, the less dense the air becomes, and the oxygen concentration in the air is reduced. So I pulled some elevation things. 42,000 feet, which is about 8 miles up. The limit of commercial airline cruising altitude is that elevation. 60,000 feet, 11.4 miles. The air pressure is at 1.69 psi with no oxygen in the air. There's no combustion with standard jet engines. Pressure suits are required for pilots to prevent bodily fluids from boiling. And then I got some records for heights of flights, and this one, August 22nd, 1963, was an X-15 rocket that crossed the Kármán line the first time. And the air pressure is at 0 or at a vacuum state, and that elevation was 67 miles. And then apparently in October 2004, Spaceship One crossed the Kármán line again, and it went to 69.6 miles. But what is the Kármán line? What is that, right? So the Kármán line, separating Earth's sky from space.
Here we go.
Wow. The Kármán line is an invisible boundary, that is used by some to limit where the Earth's sky ends and space begins.
Don't you know, brother, it's held by gravity.
Yeah, right. So the Kármán line was established in the 1960s by the Fédération Aéronautique Internationale and has been used by members, countries, and organizations affiliated with the FAI as one of the definitions of space.
Yeah, where space officially starts.
Yeah, so they say it officially starts at 62 miles above sea level. But wait a minute. If there's no physical boundary between the Earth's sky and space, then the Earth would be a vacuum without a sky, no air pressure, no oxygen, and no human life. That can't happen. So, second law of thermodynamics. Second law is the gases at different pressures will always combine to an equilibrium pressure. With no boundary between the Earth's sky and space, the 0 psi, 0% oxygen vacuum of the infinite volume of space will combine with the 14.7 psi, 20.9% oxygen of the very limited volume of Earth's air to the equilibrium pressure of 0 psi, 0 oxygen vacuum, and 0 oxygen, a vacuum of space, and there will be no life on Earth. But however, wait a minute, the fact that the Earth air always has been, is, and will be 14.7 psi with 20.9% oxygen. At sea level proves a boundary or barrier does exist above the sky because we live here and we have this air pressure, and a vacuum of space does not even encounter us. So a test with 2 vacuum chambers, both the same volume of 2 gallons, and a vacuum pump can prove there is a boundary barrier above the Earth's sky by using the second law of thermodynamics. So I'm going to go through these pretty quick. I actually have a video. I did this. I bought 2 vacuum chambers and a vacuum pump.
It's a really cool video.
And so the steps, basically what I set up was the lower, and I made the Earth air vacuum chamber lower in elevation than the outer space vacuum chamber above, just to show people that gravity keeps vacuum from entering our air. So in this case, I'm trying to equalize air pressure in both chambers. These are valves here that I control. And so right now I've got all valves are open. The valve to the outer space chamber has open valves. This is a vacuum gauge. Now the vacuum gauges are amounts of vacuum. So the gauges show 0 vacuum. When you start vacuuming the air out, then it'll show you how much vacuum is in there. Okay. So, and then of course, now with all the tubing and everything, the valves open, the air pressure in both tanks here or chambers is at 14.7 psi or 29.9 inches of mercury. They're the same pressure, just in different parameters. So now what I'm going to do here is, this is the first step. So we got all valves open. The valve here, that valve there, is the boundary between Earth's air and outer space, and it's open right now. So everything right now is at the same pressure, which is 14.7 psi. And you can read these details later if you want, but I'm walking through. So what'll happen on this next step is I'll isolate the chambers. Okay, so step 2, What I did basically, since the both valves for the Earth's air chamber are closed, so we go down here, they're closed now. So I'm separating out. I'm making a boundary between the air here in the chamber and then the air that will be coming from the chamber up here later on. So this is isolated right now. This is isolated with 14.7 psi or 29.
So that's kind of like the boundary in between the two.
That's the boundary between the two. It's not a imaginary boundary. It's a real boundary. So the next step, we're going to turn the vacuum pump on and create the vacuum in the outer space chamber above. Okay, because the vacuum's off and these two valves are open. So what's going to happen is the vacuum's going to pull the air, make a vacuum from this line and the tank. And you'll see that in the next one, because here we go, turn the vacuum on. And then now we got the arrow showing the vacuum. The pump's vacuuming out this line, but this valve prevents anything from here getting a vacuum. And it's vacuuming out, and it's also taking the pressure out of this chamber. But at this time, before I turn it on, air pressure is still 14.7 psi. There's no vacuum in this yet. I'm just showing it. So the next step is turn. No, I'm actually doing the vacuuming now. Okay, but at the beginning, because we're beginning the vacuum right now, there's no air. There's no vacuum. So it's happening now, and I'm going to turn it off. So now, outer space chamber under pressure. You can see the gauge went over to almost a full vacuum. And so, the pressure, there's no vacuum in this chamber. And then I close the valve off between the chamber 2 and the pump, just to basically isolate that out. So both chambers are isolated, separate from each other. The next step is to open this boundary valve so that they'll have equilibrium. And so now,
boom, shakalaka.
So now it's happening, but it's beginning right now. It's beginning, okay? So I'm showing what's happening with the airflow. So basically what's happening is we have both directions. The pressures from both tanks are equalizing, so they're going both ways, okay? It's going both ways on this tube here and there, right?
Yeah.
And so the next step is the equilibrium of the air pressure in both chambers is complete. So now this is where the valves open, it's been opened, they're open. So now what happened was, where we had 14.7 psi and pretty much zero, well, they bounced equal around 7 psi. So the gauges will be pretty much half pressure what each one was. The Earth chamber went from 14.7 to 7, and the outer space chamber went from 0 to 7. So what I'll do here, and we're going to show this actual test now. So it says that both chambers have the same air pressure of 7.5 psi. That air pressure is equal to an elevation of 17,500 feet above sea level. The oxygen concentration is 10.7%. Human life is not sustainable at an air pressure of 7.5 psi. So there you go. So you want to do the video now?
Right. So this video is really cool. So basically, this is a video of just all the last, 5 or 6 slides?
Yes, it's actually showing what's going to happen.
So this is the visual to what he just broke down.
Right. Okay, so this is a setup where I've got the lower tank, which is the chamber, which is the Earth's air. Yeah. And then I've got both valves open, both the one on the right and the one on the left is going to be the boundary valve. And I've got the two, and I'm showing you the gauge there. It's at 14.7 psi. And there's a tube going to the upper chamber, which is the outer space chamber, and it's above it. And there are the two valves there, which are open now, and you can see it's 0 vacuum there. So right now, both chambers are at 14.7 psi, and there's a tube that goes to the vacuum chamber. So that's the first setup. Now I'm going to close the valves. I just closed the two valves to the Earth's air chamber to isolate it. Okay. And it's still showing that it's got regular 14.7 psi pressure. The valves are open up top, the same pressure air pressure, but now I'm going to turn the pump on.
Oh,
Yeah. The pump is really cool. It pumps really down fast. Of course, the volume of the air is not much in the chambers. Yeah. So now you'll see it goes down pretty quick. There it goes. So sometimes I have to tap these because they go down on their own, but I give it a little tap just to help it out. It's pumping down. And I kept it on. I was afraid I would implode the chamber. So I got
That's
pretty.
that's the space one, right?
Yeah, this is the one, the upper chamber, the outer space chamber. Yep. And I keep tapping it. I get it down. It's like, okay, I don't want to take a chance of breaking the chamber. So now I close that valve. I isolate that valve from the vacuum pump. So now we've got basically full vacuum almost in the outer space chamber. It's
So
separated
close to a near perfect vacuum.
close to it. And then we have that isolated with a regular air pressure at 14.7 psi. And now I'm going to open up the boundary valve there on the left. Here we go. So it just equalized between the two of them.
Equilibrium.
So now they both have the same air pressure. And look, they're showing the same, it equalized, they're showing the same pressure in each chamber, which is about 7.5 psi. So that tells you right now that if I had a mouse in there, when I did that, it would die. It would die in the air chamber. So that proves the second law of dynamics right there. It's always observable. Always does
And
does
we got
that.
the perfect comment. Bam, proof of a firmament.
Right.
That's the whole point of that.
Right.
Test.
We have to have a barrier. You want to switch it?
Yes, sir.
So, conclusion. The second law of thermodynamics states gases at different pressures will always combine to an equilibrium pressure. We just saw it in a very simple scale. It's always scientifically calculable, testable, and repeatable. This law requires a barrier above the Earth's sky to maintain the perfect air pressure of 14.7 psi at sea level for life to exist. People will say, well, the theory of gravity, but people say gravity, it keeps the outer space vacuum from coming into Earth. And the theory of gravity has no effect concerning the second law of thermodynamics of gases because we had no consequence on this outcome of this test. We just did it. It did it anyway. And it's a little bit above it. It just equalizes pressure. So with no boundary, we're going to go back to this. No boundary between the Earth, sky, and space. The 0 psi, 0% oxygen vacuum of the infinite volume of space will combine with the 14.7 psi, 20%, 9% oxygen of the very limited volume of Earth's air to the equilibrium pressure of 0 psi, 0 oxygen vacuum of space, and there would be no life.
Yeah, that experiment you just did, there was no need for gravity in that.
Well, gravity didn't do anything to it. It happened no matter what,
Yes,
right?
Exactly.
Almighty God's scriptures state there is a barrier above the earth's sky, and it's named the firmament, and is also called heaven. Almighty God's creation of the firmament above earth's sky. You want to do this?
Yeah, I'll read. Since you're talking, let you get some water.
Thanks.
There's some firmament scriptures, which I thought about Psalms 19 earlier. So Genesis 1, 6 through 8, back to the beginning, gotta get the foundation. And Elohim said, let there be a firmament in the midst of the waters. Let it divide the waters from the waters. Thus Elohim made the firmament, divide the waters which were under the firmament from the waters which were above the firmament. And it was so. Elohim called the firmament heaven. So it has a name.
Yeah.
So the evening and the morning were the second day. In Psalms 19:1, the heavens declare the glory of Elohim, and the firmament shows his handiwork.
Yeah. So if you go to the firmament, Strong's H7554, or Rakia, expanse, firmament, or visible arch of the sky. Heaven, Strong's H064, Shamin, to be lofty, the sky, alluding to the visible arch in which the clouds move, as well as a higher ether, where the celestial bodies revolve air. All right, so hold on. Before we do this,
You got something you want to say?
yeah, we can just let it go. But I think this is important to talk about because we're going to show just, a sunrise to sunset video. And it's like we've been programmed by the world to think what they want us to think. And, if we can do it, just, get out of your mind. You're like, think about, okay, well, let me look at the sun going from sunrise to sunset and notice that it takes it all day. And we're just a small part of the circular level plane Earth because it's huge. And this takes all day for that sun to circuit just our part of the Earth.
Yep.
And so it just has a different perspective that it's very small. And that when we see the corpuscular rays or sunbeams coming around a cloud, that tells us that it's local. With the sun or the rays of the sun, we feel it with our senses. We feel the warmth of it.
So if it's cloudy, it's not, you don't feel as much heat.
Right. So, our senses tell us a lot of things and we need to pay attention to them.
Yep.
So I think what I want to do on this is just to show this, the sun going across the sky a day and just really reflect on that it's close. It's our time clock. It's our time clock. Only the Earth's time clock is only the heavens and the Earth.
Yep. And I just want to reiterate what he said. Something he said earlier. Trust your senses and trust what your eyes see.
Right.
The people in NASA and mainstream science don't want you to do that.
Oops.
You ready for the video?
Yeah, go ahead.
All right.
Yeah, so this is from Bristol City. Just took some clips off of it to show it, but
just the path of the sun.
Yeah, just think about that. How it's like 3,107 miles above. It's close by, and it takes all day for it to go past just the part of the Earth that you're on, which is not that much of the Earth, right? It does a lot of work. It does. Yahweh has that design. It's intelligent design by Him, perfect design. So I'm gonna get that off. That's not right. So just put it back up. I think is that it? Yeah, that's it, right?
Okay.
Yeah. So I think that's it.
All right. So
that's
was awesome, brother.
Presentation. You can check yourself. Hopefully, people understood about the latitude and longitude lines and things like that, because once you understand that, how navigation works, which took me over a year to find it out. And it's like, I got so confused when I was looking into this. Both places, it would tell me that for latitude lines, there's 360, or longitude line is 360 degrees, and that latitude lines are 60 degrees nautical mile per degree. And it's like, I'm trying to how to equate that with the circular level plane. But you saw the presentation, how they do that. They take that straight diameter line, horizontal line, of a longitude that has 360 degrees of latitude, and we get 24,856 miles of diameter. And they take that and just turn it into a circle, and shrink the true Earth size by 59%, almost 60%.
Magic trick. So there was a question. Let's see if you can see. So this was the one when you showed the slide with the 6 pictures of the moon. So this is the question off of that.
Yeah.
So Wendy asks, as the moon travels and we face a different direction, wouldn't it be a matter of perspective versus it actually rotating? Sorry if I was already late to the party. So what do you think about that question? Which is it's an interesting question.
It could be, yeah, it could. It's possible, but I mean, it does travel again. Like it's circulating just like the sun, and so it could be with that circle. Maybe that when it's going around the circle, that it's causing it to look like that. I'd have to look into that. But one thing I want to do, and maybe some people can reach out, but since the moon is so low, just like the sun, the moon is lower than the sun. What I want to do is on the same longitude line, because it's the same time zone, is get somebody that's south and take a picture same time of the moon. I'm north, they're south, and then put the pictures together, because I've seen some pictures where, they say that the moon is on the other side of the globe is upside down, right, because of the reflection. But I did see a picture from somebody from Australia, and it felt like if I mirrored it, it was almost like a reverse looking on the other side. Whereas, if I'm seeing the moon, where we have those 3 circles that are there, it would be on the right. If he was looking at it from south, looking from the south, then it would be on his left, right? Which would again show you that there's no dark side of the moon. The moon is being seen on both sides. I just don't know what the character of it is on the other side. Is it a see-through plasma?
Yeah,
so it has the same thing. So
So
that might be part of that question too, to answer that.
So if anybody's in contact with Mitchell from Australia, George would love to get in contact with him to actually do what he's talking about right now.
Right.
So if you know him personally, or you're able to get in contact with him through email or whatever, just see if you can reach out to him and maybe can make a connection with George, because that would be an amazing experiment.
And based on the fact that the moon's 45 miles below the sun, they can never cross each other. So the moon can never, and actually we know right then the moon is, basically right next to the sun, and it's below it. So how can there be an eclipse?
That is something interesting that he's talked about since we've been here. So here's another question maybe we can look at. So Sergey said, is it possible that it goes, we're talking about the moon, is it possible it goes up and down as well as in and out between the tropics? Maybe the test need to be done a few times throughout the year to check.
Yeah, but I did check it. I mean, I did check it for a new moon, well, actually 2 moon dates, 2 full moon dates, the season. So whenever you do, you can do it too if you get online. Once you understand, you can actually figure out. But what you need to do is, I know for a fact that the moon, when you look at the latitude lines, you can do it anytime, anywhere, any year in the data that you get from the U.S. Navy Observatory, because it lets you do it for either the sun or the moon any day. But the sun was always 45 degrees latitude, north or south, from where it was 90 degrees. And for the moon, it was always 44.34 north or south. And you can get online. Every time I do it, and I can do it anytime, anywhere, and you can go to any year too. You can go out 10 years, because guess what? Yah's intelligent design is logical for the sun specifically.
Yep.
So when I was saying the moon is kind of sporadic, it's sporadic only horizontally, because it's always the data always shows that it's 3,062 miles above. So, when you talk about the gates for the sun, the gates are horizontal, they're not vertical. And the other thing too is, it makes total sense that they'd have to be really close together for them to see, for our eyes, that they're the same size.
Yep.
45 miles, if they're 30 miles in diameter, it'd be 15 miles, it'd be 30 miles encroaching on that 45 miles. So it's really only, if they ever went over, the moon was over or under it, the sun, there's only 15 miles distance between them. And so that would make perfect sense that it's always going to be that elevation, so it looks like they're the same size. Now, one thing that I did notice with my Nikon camera is, I know, and it makes sense, that you can, wherever the sun is, if it's in the wintertime and it's way down in the Tropic of Capricorn, it's going to actually look smaller from here because it's farther away distance-wise, right?
Yep.
No matter what happens. So, when I was looking at the sun and trying to see if maybe I could put the moon beside the sun, it's like I can't do that, because where the moon was farther south latitude quite a bit. And I noticed that there was maybe a 15% difference in the diameter because it's farther away. That makes sense, but its elevation's the same. And the one thing too is that people don't really know the size of the sun during the day unless they have filters that they can see, which I think people should do, because it really helps you understand that once you see that it's a light, and you know, that it's like, wow, they are really close to size.
So something that's interesting I thought about earlier during this presentation, how many different experiments or tests did you mention that you've done? So we had the compass, we had the two chambers,
right.
You had the
Peephole for the
Was there
diameter.
one or two more?
That was pretty much it. The other came from the data. Understanding, it was more understanding how to navigate, and then understanding the data. And like I said, people that use a compass, they think they're on a curved earth, but it's level because the compass works all the time for them.
Yeah, but the point I was making off of that is people will say that people that reject the globe,
right?
Like I don't want to use the
Reject
term,
the globe.
People that reject it. So on our side of where I live on a flat plane and all that is, oh, we reject science. We don't like science. But you showed 3 easy experiments. A couple of them are cheap. The one with the chambers, you got to drop a little coin for that one.
Yeah.
That was not as cheap.
Right.
But if you're able to do it, and he has them in his garage. He showed me earlier. They're really cool. So
yeah.
So I mean, I think this one was very.
I also, I'm gonna do some more tests on the because obviously when the chamber goes down, that vacuum, there's no thrust in there either. There's no thrust, and I've got something I want to do for that where I'm going to show where, if I can put a fan in there and then put something that might be able to float around, and then show as vacuum occurs, it's not going to be moving around anymore. Yeah. And also, I did put some money into buying a laser where I can set something on fire inside. I'm going to do that. I'm going to make my own rocket fuel.
I've seen that before. I'd love to see you do that.
Yeah, because I want to see it myself. I'm not going to take anybody's word. I've seen some of this stuff on other videos. I'm doing it myself because I need to prove to myself. And when I do, I can say it's true.
Then you can share it with somebody else.
The truth.
And we got another question. Thanks for your compliment, Hunter. I appreciate it. He said he reminds me of I remind him of a youth pastor. So he has a question. Let's see if we can maybe address this a little bit. What would we need to figure out when the sun goes through the fourth gate? So he's obviously referring to Enoch.
Right.
He talks about the different gates.
Right.
And that is actually the gate when the new year, according to Scripture, starts, according to Enoch.
Right.
Because we don't get anything about the gates in the actual canon of 66.
Right. So that's the spring equinox area.
Yeah.
Yeah. Right. First month. I'm not sure. I know that I've seen pictures, and we can all do it. I noticed it here. I haven't taken snapshots of, the sun as it's rising, but we know that it changes where it comes to rise. And some of that has to also do with it moving from south to north, north to south. And then, but the gates again are, I think they're horizontal and they're related to obviously the seasons.
Yes, because that's a transition from one season to another.
Right.
And we are assuming that this person is referring to the fourth gate, aka the spring equinox, because they could be referring to something else. So hopefully we're attempting to answer.
I don't know everything, but I'm just kind of walking through it, and
one revelation at a time.
Yeah,
that's how it works.
I tell you what, when you ask Yah for truth and earnestly seek it, He provides it for you. And thank Him.
Yeah. So one thing you can do is use something like a sundial, because that helps with the shadows. And actually, you can get super simple with sticks and shadows, because somebody mentioned that in the comments way back about halfway through the stream.
Right.
Because like Native Americans back hundreds of years ago, they figured out the equinoxes and solstices just using like sticks and stones. So then you have stuff like Stonehenge.
Right.
So
you
can do something like that on a much smaller scale, obviously.
Right. all those point to a circular level plane too.
Yes.
I don't like to say flat Earth because that'll turn some people, like people that don't know the Lord.
That's why I called this Truth About Cosmology.
Right.
Series. So
yeah.
So let's see if there's any more in your questions. We're going to jump off here. So please do yourself a favor and George and go subscribe to his channel, because he has, I'll give you just a tidbit to maybe entice you to go over there. So he has a really cool blood moon video. He has a cool Saturn video. Do you want to talk about that for a minute?
Oh yeah. Well, when the thing was like the China balloons coming over and everyone's freaking out, it came
cover story.
It came right over Myrtle Beach here, and so we saw it. It was pretty high up. So I took my Nikon camera, and videoed it, and saw that it's a balloon holding the structure with the solar panels on it. But I posted up on Facebook and on my channel, and just saying it's a Satelloon, but of course the government had to wait a while because they didn't want to shoot it down over the land because people would see what the truth is, right? What it really is. And so didn't realize that because it was going over out to the ocean. We're here, not too far away. The next thing we heard is jets going over, and boom, boom. So they shot the balloon and the structure at the same time, but it shook the ground here when it happened. But yeah, I was just telling everybody it's just a Satelloon,
So there, after you go subscribe to this channel, there's a really cool video you can check out. So I don't know if we have any more questions. So definitely go subscribe to George's channel, and I guess we'll jump off here. Hope this was very educational, and so I would recommend probably going back and watching it again because it's very meaty.
Yeah.
And so thanks everybody for watching. Hope you'll have an amazing rest of your day or evening, depending on where you're at.
Right.
And on the flat plane.
Circular level plane.
So I guess I could say, like Wes says, shalom from under the dome.
Amen.